Yes, I can see your screen.
Okay, so I have something here. So it's just like, it is not just, it is a mind map. And that might actually be helpful to understand everything about Java, holistically. So we have this, which is the Java language, the topic itself. So clicking on this, it opens up some things on the side. We have the core concepts, we have the Java environment and development. We have the basic Java applications, classes, control statements, methods, arrays and collections, classes and objects, and inheritance and polymorphism. So I'm just going to open this up, and you can see under the core concepts, we have computers, we have data hierarchy, we have programming languages, object technology, operating systems. So under computers, we have hardware, software, organization, and Moore's law. So under organization, we have the inputs. So that means a computer, the organization of the computer is, we have the input, the outputs, the memory units, secondary storage, arithmetic and logic units, and control units. So this shows you the tree, how everything comes together, right? Then this is for computers. Data hierarchy, we have bits, which is 0 or 1. We have fields, which is group of characters. So bits could be, okay, 0 or 1, on off. Fields, group of characters, could be a word like read one. We have records, so which is group of related fields. So under this, you can talk about database records. We have columns, we have rows. Then we have files, which is group of related records. You can see the way they drop down from the smallest to the largest. Let me put it that way. So we have a file, like let's say a file, we have file. So a file can be like a paper. And under that file, you can have some records on it. And each record comprises of words, characters. And each character has, is into bits. So this is just drilling down from bits, fields, because I think I saw this question in a couple of times when I was going through some questions. So they are talking about fields, files, and records. So I think this is going to be very useful. So it's something I can screenshot and share. Then programming languages, we have the machine languages. So machine languages, we have 1 and 0. So the machine can only understand 1 and 0s. We have the assembly languages, which is like English, like abbreviations, and we have the high level languages like Java. Then we have the OOP, right? So under OOP, we have objects, and objects are reusable software components. We have classes, which are blueprints. We have instantiation, which are like building an object. We have methods, behaviors. We have attributes. We have messages or method calls. We have encapsulation, which is information hiding. We have inheritance, and we have the UML. Then under operating systems, this is where we have the kernel, we have the Windows, Linux, we have Android operating system. Then Java, all these things are things we've covered yesterday. So this is just like a recap. So for Java, we have the Java editions, which is not really necessary for us. We have the development process phases. So to develop a Java application, you are to create a file, which is going to have an extension of .java. So after creating the file, you have to compile the file. So when you are compiling the file, you are going to use a command, which is javac, and this is going to compile to .class. So your Java application that you've written, which has .java, is going to be compiled to .class file. And this .class file has bytecodes. So I saw these bytecodes in some questions also. So we have to pay attention to that. Then once you've compiled your Java application, it gets loaded, get verified, and it gets executed. So all these things are things, what's it called? IntelliJ is handling for us instead of us handling it by ourselves. What we do is just this phase 1, then we click on run and it gets executed, which is phase 5. So all these things they are happening under the hood. Then we have the key components of Java environment and development. We have the bytecode, we have the JVM, Java Virtual Machine. And like I explained yesterday, Java can run on different platforms thanks to JVM. If a platform or a device doesn't have JVM, then Java code is not going to work on it. So with JVM, this makes Java to run on different platforms, different devices. Then we have IDEs. So IntelliJ is an IDE because we use that to edit our code base, and we have some others like Eclipse and NetBeans. So that is for chapter 1. So just a recap. Then for chapter 2, we have the first program that we wrote, which is printing text to the console. Then we learned how to display tests, and we use different outputting method like print line, print, and printf. And we talked about formatting a string using %s, %d for digits, and %f for floating point numbers. Then we talked about arithmetic operations, where we talked about plus, minus, and all. That is where we are talking about the precedence and all, the operation precedence. Then we talked about variables. So how to declare a variable. And there, when we wanted to declare, what's it called? An integer variable, we thought about using ints, then which is the type. It is an integer, int. If it is a string, we are using string. If it's a boolean, we are using boolean. If it is, an array, we haven't gotten there, but we'll soon get there. So a declaration must have these two. It is very, very compulsory and important. It must have a type, which is like int. Then it must have a name, right? Which could be your variable name. Then we talked about primitive types yesterday. So talking about primitive type, I thought like primitive types are primitive, like they can never change. You can never break them down. You can never destroy them. You can never change them. Like number 1, it's a primitive type. Number 1, it can never change. Number 1 in Nigeria is the same number 1 in America. It can never change. Then we have the memory concepts. Okay, I can't remember. Then we have we are using some packages to, accept inputs and also output something out. One of them is using the scanner class. And this allows us to accept inputs from users. Then we have the system.in also. And also there is decision making, where we talked about equality operators and relational operators. And equality operators are explained because sometimes people get confused when they see a single equals to and double equals to. The two of them means different things. For single equal to, you are assigning a value to a variable. For double equals to, you are comparing, you are checking the equality. Is Ridwan equals to Tunde? You are checking, is 1 kg equals to 5 kg? You are checking the equality. Then we have the second one, which is not, NOT, not. So you are checking, it's the opposite of this. Instead of saying is mango equals to orange, or is mango as the same as orange, this one is saying is mango not as the same as orange? The two of them will give you different answers. The first one is mango the same as orange? The answer is false, because mango is not the same as orange. If you are now asking, if you are using this operator, is mango not the same as orange? The answer is true, because mango is not the same as orange. So sometimes people get confused about these things. It can be twisting sometimes. Then we have the relational operators. So this one's too, they check for relations. Is 1 greater than 2? Is 10 equals or greater than 5? So those ones are for decision making. They help you, and it is when you want to make decisions that they come handy, right? Because everything we've been saying is all about decision. You are in the market, you wanted to buy something, you are weighing them. Is this kilo greater than this kilo? You are trying to make decision based on that, right? So that is that for chapter 2. Then we handled chapter 3 also. And here we talked about methods. What are methods? How to declare a method. We talked about methods that accept parameters. And I told us like parameter is just like giving the method additional information. Cook for me is different from cook rice and beans for me. So cook for me, you are already calling a method. You are asking for, you are calling the method, you are calling for something to happen, right? And you are expecting something in return, which is the result. You adding more values to it, that is the parameter. Cook rice and beans for me, right? And these two parameters, arguments, sometimes as a programmer, you get confused like, what do I call this? So they are different. Arguments are things you supply. Parameters are like the default, what you are expecting. So don't worry. Then we talked about returning something from a method, and a method that does not return anything, it's void because it's not returning anything. Then we talked about variable types. So for variable types, we talked about primitive types, where I talked about primitive types are things like you have access to, like the money in your pockets, right now. It's something you have access to. It stores the value. The note in your pockets, 1,000 naira note stores a value, and you can use that value to buy things. So they store a value. They are primitive types, like integer, like boolean, like what's it called, character, and all that. Then we have reference types. These reference types, they do not store anything, but they store the address to a location. For example, I gave an example yesterday, like your ATM card. Your ATM card does not have, you can't say you want to buy biscuits and you give someone like, take my ATM card, just keep it, give me biscuits. It doesn't work that way. But it references the money in your accounts. So you can give someone your ATM card, they put it inside the POS, then the POS connects with your bank account because that is where your money is. So they reference something, they reference an object's location. They have the address to the object's location. Then we talked about instance variables, where we talk about fields, attributes, and all that, where we mentioned behaviors and all. Then we talked about local variables. So everything we did yesterday was actually, not just local. So we thought about local variables also because we used primitive types yesterday. We used reference, we used instance variables and local variables. Then under class, objects, and method, we have methods, variable types, constructor, and I talked about something about constructors. You use constructors to initialize objects. And I gave an example yesterday, like if you bought a phone, for you to set up the phone, it will ask you for the language, it will ask you for some things. You are initializing it, initials. You are setting it up like, oh, before you do this thing, I'm going to set it up with some things for you, right? For example, you want to give your kid maybe food. You have to put some things. Maybe you set it up and all. You set it up for them. Then they can now do some other things on it. You understand? Then we talked about setters and getters. And I said setters are accessors because they access something. No, sorry. Setters are mutators. They modify things. You have something, you have a variable, you want it to be changed, but you do not want an outsider to have access to that variable. Maybe the variable is private. You can do a setter method for them to set it. And to get something back, for example, okay, this setter, you can say, let's say you have an account with a bank. You send money into your accounts. You don't know what is happening. You don't know what is happening behind the scenes. What you know is, you click a button on your application to send money to an account. That is, you are setting something. Oh boy. You do not know what is happening behind the scenes. Getters are getting things. Even you do not know what is happening behind the scenes. An example is you log into your application, you get your balance, right? You refresh it, you are getting your balance back, or transaction history. You don't know what's happening. All you are getting is just results. So you use getters to access and setters to mutate. Then we thought about floating point numbers like decimals and all. Then string concatenation. And we also talked about this plus and plus equals to yesterday. So where we stopped yesterday was control statements, which is where we are going to kick off today. So yesterday we talked about algorithm, whereby I gave some analogies of algorithm and. Then we talked about sequential execution. transfer of control, structures. So under control structures, we have sequence structure, we have selection statements, where we have if, else, if. We didn't do a switch yesterday, so we are going to do switch today. We talked about repetition statements, while, for, do while. We stopped at while, so we are going to do for and do while today. And you are going to see the difference between the three. Then we talked about stacking and nesting, and I made mention of something else like you have to be careful of nesting loops. Then repetition types. So yeah, we've done this one yesterday where we talked about the counter control and sentinel control. Then we talked about increment and decrement operators. So, and I gave us the difference between this plus plus a and a plus plus. And I gave us the reason why you might not want to use one of them, you know. It's actually a good thing, but then you have to be careful. Did we talk about logical operators? No. So we are going to do this today and break continue today. So today we'll be looking into methods, all this modularization, reusability, and all. And we'll also be looking into arrays. We'll also be looking into class and objects there. And lastly, we'll be talking about inheritance and polymorphism. So we can now start our class now. So let me just switch to the other screen. So if you have any question at any point, I might not be reading the messages, just ask, right? Just ask. So I'm coming. Okay. Yeah. Please go ahead.
Sorry. Thank you. The part that you just showed, can you give us a screenshot that you said?
Okay, no problem. I'll do that. I'll do that.
Right, thank you.
Stuff. Right. All right. Yeah. So we stopped at we stopped at increment and pre-increments yesterday at the post increments. So today we'll be moving on to chapter 5, which is control statements, the part 2. Then from there we'll move on to all others. And so control statements, we've learned, where is it? Part 1. We've learned if statements and while loops. And I told us like you use the if statements and while loops to control program flow. So now we are going to expand with for loops, and we'll still talk about we'll talk about do while loops, switch statements, then break and continue, logical operators, and a structured programming summary. So all these things, they are going to give us more ways to repeat actions, and they are going to give us more powerful decision tools, right? So since we already know if and while, so we are going to be learning more repetition for like using for and using do while, more selection using switch, and more flexibility using break and continue. And we are going to be making smarter decisions with the logical operators. So the question is, we have this part 1 and part 2. Why do we need more control statements? The reason why we need them is because they let us undo varied inputs and repetitive tasks efficiently. So someone might think, oh, I'm okay with the if and while stuff, so why do I need more, right? And they're also going to prepare us for real-world programming challenges, because you might think like, oh, everything ends here. It is possible you might meet yourself somewhere whereby you are exposed to more advanced codes and you'll be like, no, I've never seen this before, right? But you getting like seeing it for the first time, or maybe, you know, getting yourself familiar with them, you'll be like, no, it's something I can do. So talking about for loops are counter-controlled repetition. And what they do is, it is very useful when you know exactly how many times something is going to be repeated. For example, I went to the ATM machine. Is it ATM? or ATM machine, anyone. I went to the ATM, I input my card, I want to withdraw 10,000 naira, right? Machine already knows. Once I input 10,000, it knows like it's going to repeat. If it is 1,000 naira notes, it's going to repeat this action 10 times. So for that, there is what you can use to loop, because you already know the end goal. You already know how many times you want to repeat an action. So you count 1, count 2, count 3, count 4 to 10, and 10,000 is complete. Then another example I can give is, I want to give Ridwan 5,000 naira, for example. You have the cash. You count 1, count 2, count 3, count 5, then you stop. So you've performed a repetitive action, right? And that is where for loop comes in. So for loop combines, it combines the initialization, it combines a condition, and it also has the increments, everything in one line. So most times they call them iteration methods. So I'm going to, like we did yesterday. So I'll copy and paste the code, then I will explain line by line what they mean, so that if we have any question, so my goal is just to unlock us, so that we understand these things. So I have a for loop program here, and I'm going to run this code, then I will explain what is happening. So if I run this code here, check my console. The result is I have 3, 4, 5, 6, 7, 8, 9, 10. Why? So let me break it down, right? We already know what this is, which is the name of our class and setting up our class. And inside it, we have the main method, which I explained to us that it is the entry point to a Java application. Then starting from here, this line 3, we have 4, and inside the 4, just forget about this curly brace first. Let's talk about this. So we have 4, and inside the brackets, we have int counter equals 1. We have semicolon. We have counter less or equals to 10. We have followed by a semicolon. Then we have counter plus plus. It's looking familiar, but in a different arrangement. It looks familiar to what we did yesterday, but in a different arrangement, because everything here is on a single line, right? So this is what they call for loop. This is the header, for loop. So for loop controls the iteration. So here we have the initialization, which is int counter 1. Let me zoom. We have the initialization, which is int counter 1. Int is the variable name. Sorry, int is the data type. Counter is the variable name. We have the operator, the assign operator or something, and we have the value here, right? So the loop, this is called the loop control variable. This counter, it is the loop control variable. It controls the loop, and it is initialized to 1, which means this happens only once. Even if it is 100 that is here, this particular thing happens only once. It means this is where we are starting from, our starting point. So, but this one is initialized to 1. Then moving away, we have the condition. Condition is counter is less or equals to 10. And like I said, we've initialized this to 1, which is the initial value. It is 1. So here, it means is 1 less or equals to 10. So this is going to give us true or false. That is the condition. This is the, let me just write it out. So the first step is initialization. The second step is the condition, which must be true or false. And the third step is the increments, right? So we have the initialization, we have the condition, checking for something, checking for true or false, right? And we have this counter plus plus. This is the increment. So which means after every successful iteration, excuse me, after every successful iteration, counter is incremented by 1, right? And after this, we have a block of code. So what is happening here is the program comes here, it says, oh, this is a for loop. So this is an iteration. So what am I going to do? The information here is going to give the program everything it needs to do. So what it's doing is, oh, this is a for loop. The first thing I saw here is counter is 1, okay? And what is the condition? The condition is if counter is less than 1, less or equals to 10, perform everything that is here. So once you are done performing this, then come back here, increment counter to +1. So now counter becomes 2 because this one is saying counter +1. And we know initially what is counter? Counter is 1. Okay, let me just come again. The program comes, sees a for loop. The first thing it checks for is what is the initial value. The initial value is we have a counter, which is a variable, and it holds 1. So which means I'm starting from 1. Then what is the condition? The condition is that anytime 1 is less or equals to 10, no, run the code here. So after you've run the code, increment the value of counter by 1. So right now, 1 becomes 2. The program comes again. Is 2 less or equals to 10? It is true, yes. Then run the program here. Once you are done, increment counter by what? By 1. Counter becomes 3 here. It goes again. Is 3 less or equals to 10? If that is true, run the code inside this. After running, increment the counter by 1. Counter becomes 4. Till counter gets to 10. So by 10, the code comes here again. Counter is now 10. Is 10 less or equals to 10? This is still true. Oh yeah, run this code again. Only increment by 1. Now counter becomes 11. The program comes here again. This is 11. Is 11 less or equals to 10? This is false. Then counter and the program will be like, oh, then my work is done. So let me move on to the next stage, which is this. Then I'm done, right? So I'm coming. So what is happening here is we've seen we have 1, 2, 3. We've seen what we have on this console. It prints every time counter equals to a number, it prints it out. Because that is what we are doing. So I hope this is straightforward and easier to understand. Okay, please go ahead, please.
If we are going to implement the counter more than 1, how do we define the statement?
If you are doing what? I can barely hear you.
If we are incrementing the counter more than 1,
yes.
By 1.
Okay, like this, right?
By 1, right? Which is more than 1. Supposing incrementing by 2.
Okay, incrementing by 2.
Okay.
So in that case, you can actually, because you can see I incremented it by 2, but it's not, let me say 2. It threw an error here, which means this is not a statement. So what you can do most time is you can use an if, though there is an advanced way of doing it, but based on what we've learned so far, you can use an if to write all these things. So what we are doing here is you can use an if, and you can say if counter, which is similar to what we did yesterday. If counter is less than 10, or let me just do another one. If counter 2. So you can now do int counter 2 here and initialize it to 1, right? So if counter 2, if counter 2 is less than 10, then print this out. Let's print counter 2 out. Then after printing, now do counter 2 equals to counter 2 plus 2. So here we are incrementing by 2. What's this? Condition counter 2 is always true. Okay. Counter 2 here, because we are, yeah, I'm coming. Let me do counter 2 plus equals to counter 2 plus 2. Yeah, it's still correct. So let me run this and see what we have. This one ran just once because this is not the value counter 2 assigned is never used.
I have a question.
Yeah, go ahead, please. Don't worry.
Yeah, so for the for loop now, can't we use counter equals counter plus 2 at that side at the third something?
Yeah, right.
Yeah, the third one, yes. Counter equals counter plus 2.
Oh, it works. Wow, thank you for that. It actually
Yeah.
works. That
So,
makes sense.
and I have a question. My main question is, since this first system.out prints the code, prints the 1, 2, 3 to 10, then
Yeah.
why do we need the other system.out, the other one outside the for loop? Why do we
This
need
one.
that?
So
Yes,
apparently it's just to, you can see there is a space after this line. So this is the space. It's just to have space. So if we do not want it, it's something we can comment out and it's still going to work. It's just to make things neater. You can see it.
Okay, all right,
You
thank
can
you.
add it to the beginning also, it's just to add, just to make something neater, sure you get.
Okay, all right, thank you so much.
You're welcome.
So then I think the counter equals counter plus 2.
Yeah.
I'm not sure, but can it be written in the shorthand form? Say counter plus equals 2.
Okay. All this should be things you practice with personally. It's actually work. But I mentioned something yesterday about plus equals 2. And I think I mentioned something yesterday regarding this.
Yeah, that it's easy to mismanage.
Right. But most times then there might be some confusion coming in. But this works actually. This works. Because we have so we can also add, you can add more if we do 5. So this means this is going to run how many times? Maybe 2 times. Yeah, this ran 2 times. Like we have a 1 and 6. So I think we are clear on this. All right. Then should we do one more example? So let's do one more example, which is summing even numbers, right? So let's call this sum evens. So this is going to be a program that sum all even numbers in a. So this, so this is pretty straightforward, but then I'll still explain so that the more we hear it, the more we get familiar with it. So let me run this code first and we'll see the results. The result is sum of even integers from 2 to 20 is 110, because it is possible someone can just ask you, or you have something and you tell like it's on. So what is happening here? We have the normal rule initialization. We are initializing the total to be 0. So this total is going to be acting like the accumulator. It's accumulating for the sum to 0. Then we have the for loop, which is this. And the for loop, we have the initialization, which is initialized to 2, which means the counter starts counting from the first even number, because 2 is and 2 is the first even number. Then we have the condition, which says if number is less or equals to 20, if it is true, then run this particular code. And what is happening here is, and we also have the increment, which is also incrementing the even number by 2, which means if the initial value is 2, by the time the code here runs, the next value is going to be 2 plus 2, making it 4 here. So we are dealing with even numbers already, right? So the calculation is this total that is initialized to 0. We had the current number to it. Presently, number is 2. Adding 2 plus 0, this becomes 2 plus 0. This becomes, this gets to 2. Then the next time we run, so after running this to 2, the counter changes from, sorry, number increments by 2. So here we have 4. So it checks again. Is 4 less than or equals to 20? It is true. Then add 4. 4 to 2 equals 6. Then it comes here again, increments number by 2. Then this becomes 6. It checks again. Is 6 less or equals to 20? It is true. Then add 6 to whatever total is. 6 plus 6 equals 12. So it goes on and on till this becomes, I think, 22. Yeah, because 22 is even number. So it gets here, it says, is 22 less or equals to 20? This is false. Then it terminates. And the next thing is we are printing out our result, which is sum of even numbers from 2 to 20 is these digits, which is the total that we are giving. So this percentage D is the placeholder, and this is the value that is going to go into it. And we have this. So that is pretty straightforward, right? So I think we can just move on to something else so as to save time. So let's talk about do while loop. So do while repetition, do while, do, and this one too, the English is straightforward. You are saying do something while something is happening. Do this while this condition is met. Yesterday we talked about while loop, which means while this condition is true, do this. So both of them are different. We have while loop and we have do while loop. So these two, they are different, but they are kind of similar. But there's something that makes them different, and it might come from the question like, what's the difference between the two, or what do one of these do? So for do while loop, it tests the test condition comes after the body executes. So that means this is going to guarantee at least one iteration, at least one execution is going to happen, at least one. While loop, it might happen, it might not happen if the condition is met or not. But do while loop, whether the condition is met or not met, but something must happen. Something must happen. So do while loop always run at least once. I'm saying this again. Do while loop always run at least, whether the condition is true or not, it must run at least. So if the condition is true, then it keeps running based on the condition until the condition becomes false. If the condition is false from the beginning, it must run once, then it will stop. So, and the reason is that after running, it checks the condition at the end. It doesn't check beforehand. For example, you are with the ATM, you want to withdraw. What they do is they check first why your balance is greater than the amount you want to withdraw. Then go ahead. But can I? Okay. Okay. An example for do while loop is, let's say you are testing different. You are trying a new food, right? You must taste it once before deciding whether to keep eating or not. You understand? At least you must. You can't say a soup doesn't have Maggi if you've never tasted it. You can't say. So you have to taste it once and say, oh, this doesn't have Maggi, then I cannot eat it. Or this doesn't have salt, I cannot eat it. So you must perform an action first before the condition. So if they tell like, okay, you can say, taste this food while it has, what's it called? It has salt, then continue. So if you've tasted it and it doesn't have salt, then you stop. So which means you have performed the action. That is the action, do. You must do something. Then check for the condition. So I don't know if that makes sense, the way I use the example. So let's write a code to check for do while loop. So and I'll put the while loop. I can't remember where I put it. I'll put it. Okay, this is it. I'll put it side by side so that we can see what is happening there. So let's write another program for that. So we are going to call it do while. Do while. Let's give it a name because we are testing. So we have while loop test. Do while loop. Okay. Yeah. So for do while loop, let's copy and paste as usual. Then so what we have here, you can see. Let me run this first. Then let's see what we get. So it says enter a number. So if I want to stop, I enter 0. Let's assume I want to stop. I enter 0. Press. So it's run once, and it runs once. So let me try something again. Let me rerun it. So enter a number. Let me enter 55. Then you can see it continues. It will keep continue until I enter 0. So if I enter 0, it will stop. So let me explain what is happening here. You can see the way they wrote it. Do while. I really wish I could open the while to the side. I don't know how, is it possible? I don't know. So let's check while. This is what we have while. You can see while comes first. We have while, we have the condition inside while, and we have the body of code after it. But for do while loop, we have where is the while? So we have do first, then we have the while with the condition, right? So you can see the difference. So do, this one will print first. For the first time, it's going to work. So what is happening here is this particular program, this particular code, it is designed to like continuously prompt the user to enter numbers until they enter 0. Then after entering 0, it's going to calculate the sum total of all the entered numbers, excluding the final 0 they entered to stop. So the breakdown is that we have our class name, which is normal. We have the entry points, and we have scanner. So we are using scanner objects. You know, we have the, what's it called here? The variable named inputs. Like I said, you can put this one for anything. You can put this one to be read one, but just to make your code readable, you have to use something that is meaningful to you and to others. Then we are using this to, you know, read user inputs. Then we have two variables here. Int number. So this one is going to store the user, the number the user currently enters. Then we have int total, and this is going to sum the, is going to store the sum of all the numbers entered, right? Then here, this is the do while loop. So in the do while loop, we have the do block. You know, anywhere you see the curly braces, we call them block. The parentheses, we call them block because it's a block of code. So we have the do block, right? The do block executes at least once, regardless of this condition. So, and what is happening inside this do block? This is an information to the user, and it's saying enter a number, and whatever number the user enters, which is an integer, we store it inside this variable number, right? So after storing inside this variable number, we are adding it to total. Whatever total is, like we already know, this is the same thing as saying total plus number, right? Oh, sorry. This is the same thing as saying total plus number, right? So we are adding whatever the user inputs to number, to whatever number is at that particular point. So presently, number is 0. So when the user, which is Ridwan, enters 55, we did 55 plus 0, making 55. So Ridwan entered 76 again. So we are saying 55 plus 76, that should give us 126 or something, right? So I don't know. So that's what we are doing. And that is that for this. So after doing that, it keeps checking this condition. So what is the condition? The condition is that is number that the user has entered not equals to 0. So I entered 55. Is 55 not equals to 0? 55 is not equals to 0, and this is true. Like I said the other time, this and this are different. This one is 55 equals to 0? This is false. But is 55 not equals to 0? This is true. You can see the difference. So is 55, which is the number the user entered, is it equals to 0? Is it not equals to 0? It is not equals to 0. That is true. Then continue, right? So once the user inputs 0, then the loop terminates. I hope we understand what happens. So after the termination, it now finally moves to the next line, which is printing the total. Whatever total is the value, it prints it out to the console for us. So that is what is happening with do while loop. Do we have any question? Is there any confusion with while loop, do while loop, and while loop? So if there is no confusion, then I can, like I said again, while loop will run, while loop, which is this, will run only if a condition is true. That means this might run or might not run at all. It's either it runs if the condition is true, or it doesn't run at all. But for do while loop, it must run at least once. So like I said yesterday, for while loop, you are saying while it is raining, then put your umbrella up while the condition is true. So which means if it is not raining, then there's no point putting your umbrella up. But do while loop is saying, where is it? It's saying, Alice, taste this food, then check if it has salt. If it has salt, continue eating. If it doesn't have salt, stop, terminate. So at least you must have tasted the food first. You must have performed the action. While loop, if the condition is not true, no action is going to take place. Do while loop, whether the condition is true or not, at least one action must take place. So I hope that is clear. Then next, we'll move to, if there's no question, I'll move to the next one so that we'll do this very fast. So we'll move to switch statements. So switch statements, they handle multiple conditions with case labels. So they are used when you have choices based on one value. You have many choices, but based on one value. And I'm going to, let me quickly show us. Okay, let me give an example of how that works in real life. So let's say you are at what's it called? Our outing, right? Hold on, please. Sorry. So let's say you are at the lounge, like after the exam, and they give you the menu. So number 1 is burger, number 2 is pizza, number 3 is rice, number 4 is beans, and the last one is sorry, not available, like when you're trying to order. So they've given you multiple options to choose from, but based on one value, and the value is that you want to order for food. That's the only value. The value is okay. Another case is you have Monday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. You can only have one value, which is a day. And what is the day? The day is on Friday. If the day is met, then do this. So if today is Saturday, then do an exam. So I'm going to show us an example of that so that it makes sense. So let's say we have let's write let's do, what can we call it? Let's call it switch day. Switch day. So inside this switch day, let me just do public, let me copy, type in one after the other is something like that. Okay, let me just copy this and go to switch day and paste it here. So I'm going to clean this up. I just want to show us today is a string, and the string, let's call it today. And today is what? Today is Friday. Friday. Then if you want to use a switch statement, you go like, so you do switch. It's a switch, then it has this bracket, and you have the, what's it called? The block of code. So switch, right? You have switch, inside it you have block of code. So what is happening here is you want to give it what's it called? The value. So you say, let's say today, and we have different cases. Case one is if today is Monday, let's say, what can we call it? Okay, let's just do case one. So this one will print out, let's print out something. So we are numbering our days from number 1, number 2, and number 4 or number 5 will be Friday. So let's do it that way. So we say print, this is why I don't like typing, it becomes an headache. So I just want to show us something, then we can now do something more, what's it called? Break. So I'm going to be copying this. I just want to show us what do we have here? Oh, this is a number. Let's say it's Monday. This is what? When is not reaching day. Let me just copy the stuff so that I won't waste time. I just want to show us with day or something coming. So let's do another one. Let's do switch. Let's have the class switch test. That's Java. Then this is going to be a lot, but I will explain. Don't worry. Yeah. So I'm going to explain what is happening here. Then we are going to run it. Right. So what we have here is we have a switch, we have a program, we already know all this. So we already know all this, scanner, blah, blah. Then we are using a while loop here, right? What is happening here is we are saying if, okay, let me go again. We are expecting a value from the user. We have some variables. The first variable is grade. The second variable is total, which is going to be, summing up the grades. And the third variable is going to be a counter, a grade counter. So, which is what we are trying to, we'll be incrementing this, right? And after that, we have something prompting the user for an information. What's the information? The information is that the user should enter a grade from 0 to 100. And they should use -1 if they want to, stop the execution. So whatever value the user inputs, we save it to this variable, which is grade. Then we are now saying that while grade, whatever the value is not equals to -1, then perform the operations here. So we are just adding this so that, we know when to stop, so that when the condition is met, then we can now stop, right? So inside this while block of code, we have the switch statements there. And what the switch statement is doing is, it's taking the grade, whatever the grade is. So if the grade is, let's say the grade is 5, it says 5/10. And 5/10 is going to give us, what's it called? Then we are now saying that if the case is 9, don't print out anything. But if the case is 10, print out something. Then we have another statement here, which is break. Then if the case is 8, that means if whatever thing that the result that comes from here is 8, then do this. If it's 7, do this. If it's 8, do this. So at the end of the day, after the switch statements, we are now saying we are doing some calculations here, right? So let me run this first. So I input 3, I input, you can see. So as I'm inputting something, it's actually printing out something for me, which is F. So what if I input 5, self, I input 9, F, I input 1, F. So from 100. So if I input 50, F, if I input 90, A, if I input 67, D, if I input 80, it brings out B, right? So how do I explain this? How do I explain this? We have, okay, let me go over this again. This particular switch statement. Inside this while loop, right? We have a switch statement that determines the letter, the letter grade by dividing the numerical value by 10. So if I input 80 here or 90, so 90 divided by 10 gives me 9. If I input 80, 80 divided by 10 gives me 8. And if it is 8, then definitely the student gets a B. If I input 100, 100 over 100 is 10. 10 gives me an A. If I input anything less than, let's say 50, 50 over 10 is 5. There is no 5 here, which means by default, anything that does not exist is going to be this. So that is the grading score that we did. So the switch statement is checking for a case. So if the case matches whatever thing that is here, then it prints it out. So which means case 9 and case 10. Let me just do it so that it makes sense. So instead of having it here, because it can be confusing. Yeah. So case 9 and case 10, they are printing A out. So if a user gets, let's say a user gets 90, 90 divided by 10 is 90 divided by 10 is 9. So if a user gets what's it called, 9, then they are still on A. But because they are the same, that's why I left it the other time. So that it makes sense now. So I'm going to have it back. So at the end of the day, we have a default, because when you are writing a switch statement, after writing all your cases, all the conditions that can be met, you must have a default just in case none of this is true. Just in case nice one. Just in case none of this is met, then there must be a default value. Like if a user doesn't get up to that, then there must be a default value, right? So then we have a while statement that is checking for a condition. If it's checking for all numbers, all valid numbers, if it is not -1. So that means if it is -1, you must what? You must terminate the program, right? So if grade counter, which is this, is greater than 0, it calculates the average here. So it calculates the average here, right? After calculating the average, which is this, it casts the results, to a double for precision, right? So it casts the results to a double. Then it displays the total number of grades and also the sum, and it also displays the final average. So if no grades were recorded or were entered, it's going to print out no grades were entered. So all these are just checking to make sure like we have a safe proof program, right? So another thing is, in your case, in your switch statements, always use a break after each case. Always use a break after each case, unless there is an intentional fall through. But always use a break. So if you don't use a break, the break is telling the system to say, okay, after you've checked for this condition and it has been met, then you know what, leave the switch statement and perform some other things. If you do not use a break, you are actually introducing a bug into your code base. So which means if 100 divided by 10 is 10, the program will be like, oh, this user gets an A. But there's nothing to stop me. It continues again. Oh, it's under A. Continues again, another B. Before you know it, somebody that gets or got 100, they are going to end up having B. They are going to end up having F. So that is why it's always, you are telling the program to take a break, like to break off, to terminate from that particular point, because the condition has been. So if the condition here is 50 divided by 10 and it is 5, it gets to 5. 5 is actually, so since there is no case for 5, then it defaults to this. That's why the other time, if I enter 50 here, it defaults to F, because that is default. None of these conditions were met here, and the default is F. So if I enter 40, it defaults to F. If I entered 20, it defaults to F. But immediately I entered 60, or let's say 61, it defaults to D, because D, there is a case for D, right? So that is that about switch statements. The rule is that for a switch statement, there must be something they want to check for. So here we are checking for the grade and we are dividing it by 10. So we are saying that if the grade by 10, whatever the answer is, check for the case inside there and make things happen. So that is that about switch statements. Then, like I said, there is something called break, which is this. And there is another thing called continue. So they are opposite of each other. So break is, break is exit this loop or switch from this loop immediately once the condition is met. Once you met this break keyword, then we have continue. Continue means skip the current iteration and go back to the loop condition. Excuse me. So break is just like having a stop button. Like let's say you have a microwave and there's a stop button, like, oh, I can't wait for you to finish all this thing. Just press the button and it's going to halt. It's going to stop the cooking immediately. Then continue is like, maybe you are picking beans and you see a bad beans, you see a bad one. You just keep it. You don't pick it. You are picking the good ones from the, you have beans in a tray. You are picking the good ones out of the tray. Once you get to see the bad one, you just skip it and move on to the next one. So that is break and continue in a nutshell. And we can have, should we have a, okay, let's do it. Let's have an example of break and continue. Break, continue test. Yep. So after this, we'll move to the next one so that I won't waste time. Yeah. So I'm going to, then I run this and we have these results here. So what is happening here? What is happening is that we are using this particular program, right, to demonstrate break and continue, to see the difference between break and continue. So here we have for loop. The first for loop here is counting from 1 to 0. To 10. It's counting from 1 to 10. So when the count is equals to 5, the break statement here is executed, which immediately exits this entire loop. It exits the entire loop. So at the end of the day, what we are going to have is, let's say 1 is 1 less than 10, yes. 1 plus plus, so it's 1 less than 10. We have, so this is going to print 1 to the counts. And sorry. So we have 1, then it checks again. It increments 1 plus 1, making 2. Check again, this becomes 2. It's 2 less than 10 years. If 2 is equals to 5, break. 2 is not equals to 5. This prints it. It prints, then it prints to 4. Then when we get to 5, count is now 5. Is 5 less or equals to 10? Yes. 5, okay, then it comes to this to check the block of code. Is 5 equals to 5? Yes, 5 is equals to 5. Then it sees this break. That means this is going to exit the whole for loop because we've told it to break off. So it's breaking off here. Then it prints this out, which is broke out of loop at count equals to 5, which is what we have here, right? Then that is for break. Then for continue, we have for loop, which is starting at 1, and we are checking that is 1 to 10, right? We are saying the same thing. If 5, I've skipped 1, 2, 3, 4, we've done 1, 2, 3, 4. Now count is 5. If 5 is equals to 5, then continue. I love it. Just continue. Continue whatever thing you are doing. So this continues, and it continues till this condition is met, which is by then we would have reached count will now be 11. Is 11 less or equals to 10, which is false? Then it now breaks off from this loop, and then it moves to the next one, right? So that is why we have this here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we are printing out skipped at 5. So that is the question is, when do you use break, and when do you use continue? You use break if you want to exit early. If you want to come early, you use break. So that break, like just like I can't continue again. I'm breaking off. I just want to take a break. So you are breaking up early, like you are stopping that execution early. Like I don't tire. I can't continue with this. I want to break off. So once the condition is met, you break off the whole loop, and that's it. You go back to rest. Continue means, guy, I'm enjoying this. Just continue. Sometimes this is useless because you hardly see it in code. Like, why you? Because even if you do not put continue and the condition is not there, it's still going to continue. But sometimes there will still be some use cases whereby you would want to use it, depending on how complex your application is. So that is that. Then let's move to the next one, which is logical operators. In logical operators, so when we are talking about logical thinking, right? I used to tell people, like, I really wish they could introduce that to primary school curriculum because it makes students to think very well. So logical operators, we have the and, we have the or, and we have the not, right? Let me just, how can I? Okay. So this one is and, we call it and. This and ampersand. Then we have the or. Don't mind this how I'm doing it. I'm just trying to show you the relationship or what it means. Then we have the not. So this not is it reverses truth. So for the and if there is this law, if both what's it called, both things are true, then this gives us true. Is Barry and Ridwan a students, then it is true. Or if Barry and Ridwan are students, then that is true because Barry and Ridwan are students. It is true. But if Dr. Aziz and Ridwan are students, do this. The condition is if both of them are students, and that condition is false because both of them are not students. So then you don't do anything. Then the or, if Dr. Aziz and Ridwan, if one of them is a student, then do this. So far one of the conditions is met. One of the conditions, so far it is met, then that execution is going to proceed. Then we have this, and also, so the condition is that one of these must be met. Either one of these or both of them must be met. Either one or both. But for this one, both of them must be true. For and both must be true. True if both are true, right? For or, true, it is true if at least one is true. Then for this not not reverses, it reverses truth. So there is this thing like programmers used to do. They used to scam their girlfriends. They write something like, I love you. They just do, I love you. And they will put exclamation mark here. So this means I, the opposite of love, and you. So it could mean I not love you or I hate you or something. So if you see this, it means it reverses that true. Whatever it is here, it gives you the opposite of it. Which means, so if you have true and you have this behind it, so this is false. And you can have this also. It's getting tricky. So we have not true. So what would be the answer? The answer is true, right? The answer is true. And the reason is that, this first one, not true, means false. Then this one is saying not false, which means true. You can see how tricky it is. So sometimes in any programming stuff, you see this. I don't use, because anything other than banana, me, I know they chop. So I know they use all these things for my program, because I'd rather write this right away, false or true. Because I can come back later and the thing will just be banging my head. If I see double exclamation and I'm seeing true, like, what's going on here, bro? So where do you use it? You can use it for, let's say you have a child. Okay, let's say you have a cinema, right? The condition is that for you to enter the cinema, you must have your ID card and you must have your ticket. Or let's say, okay, the exam we want to do, right? For you to enter the exam hall, you must have your docket and you must have your ID card. So ID card and docket. If you have one of them, you are not entering. That means you are not a student. It's not true. If you have both of them, you are entering. If you do not have any of them, you are not entering. So that is where you use and. ID card and docket. If they use or, it will be ID card or docket, which means if you have one of them, you can enter. If you have both of them, you can enter. If you do not have any of them, you are not entering. At least one of them must be true. Then this one reverses it. If a student does not have what's it called, a docket, they should enter. But if it is not, how can I use it? But I'll use for another analogy for it. Okay, another analogy is I am not happy. Yep. So using this, I am not happy. I am not happy. So this means the opposite of happy. So if you do, like I said the other time, this is I am. If you do I am happy, it means I am not happy. So which means the opposite of happy, right? So to enter the lounge, you must bring in your cash or your credit card. Let's say after the exam, you are going to the lounge and you want to enter, and the condition is either your cash or your credit card. So if you do not have, either your cash or your ATM card, if you do not have the cash or the ATM, you are not entering. But if you have one of them, then you are good to go. So that is the, what's it called, logical operator. It is for logical operations, right? And let's just write a small code to see how that will work, in a program. So let's say we have logical, let me just call it logical test so that we can have another program. So all these things, it's possible, like you can see it in your question, whereby they'll be asking you for logical operations, like what does this, exclamation mark, this, what does it mean? Oh, sorry. I'm sorry. So we have logical operations here. So I'll run this code and I will explain what is happening here. You can see my console. I have enter a number from 1 to 100, right? So if I enter, let's say I enter 40, for example. So if I enter 40, what's going to happen? It says number is between 1 and 100. What if I enter, let's say I enter, I'm not following instruction. Oh, sorry. So if I enter 1000, what's going to happen? It says number is out of range, outside 100. What if I enter 0? or minus, let's enter -1 because we are okay. Let's enter 0. So if I enter, I have to zoom this. So if I enter 0, it says number is out of range. So what is happening here? So this code is actually demonstrating the use of logical operators, right? And the and, the or, it's demonstrating them. And it's checking if a user has entered a number that falls within or outside this range, which is 1 to 100. So we have a scanner expecting an input, taking inputs from users, and storing that input in number, right? A variable number. So what is happening here is the first one here, which is this. We are using our if statements. We are saying if number that the user has entered is greater than 0, and you can see the second number is less or equals to 100, then print out number is between 1 and 100. So let's try that. So I input 5. We know that 5 is greater than 0, but 5 is less than 100. This condition is met. So if I input this now, you can see it says number is between 1 and 100 because 5 is between 1 and 100. It prints this out, right? Else, if this condition is not met, that is, if number is not greater than 0 and number is not less or equals to 100, then print out of range. Then another condition that we have is if number is less than 0, or you can see, or number is greater than 100, then print this out. This is pretty straightforward. So, and like I said the other time, this condition, both of them must be true. So the number I entered is 5. That means 5 is greater than 0. This is true. So let's just write this. 5 is greater than 0, true. And 5 is less or equals to 100. This is also true. So true and true gives you true. True and true gives you true. Once you have true and true giving you true, then what happens? This condition is going to, true and true gives you true, then this condition is going to run. But if one of them is true and the other is false, let's say true, let me just shift this back. Let me go. Sorry. I love it when one of the reasons so if one is false and the other one is true, what is going to give us? The rule is this is going to be false. It's just you have, just like in mathematics, you have -1 times 10. It's going to give you -10, right? So that is what is happening. Once there is a negation anywhere, it invalidates everything. It's just like you have a sheet dropping into your beans. You don't eat that beans anymore because you don't even know. So once one negative comes in, then all the vibes are gone. So once one of them is false, either the first one or the second, and you can have as many conditions as possible. You can even say, and number is not, let's say 500. So a number is not 500. Then condition number is not 500. What is it? Yeah. So you can have as many conditions as possible on a single line. That is one. So I'm saying here, if both of them are true, this condition is going to run. If one of them is false, then it defaults to false. This condition is not going to run. If both of them false and false, if both of them are false, then this is going to be false because false and false is false. Then nothing is going to happen. If Ridwan is a female and Barry is a female, then open the class. Both of them are not female. So that means the class is not going to be opened. So this is going to be false, right? Then talking about or, so now let's flip the coin. So coming here, the thing is, one of these must be true. So if both of them are true, then this condition is going to go. If one of them is false, then the condition is going to go through. It's going to be false. So you have to pay attention to this thing, because sometimes it can be tricky. If both of them are false, then it is false. Because we are saying if Ridwan is a female or Barry is a female, open the class. The statements, both statements are false. So that means the condition is false generally. But if both of them, if Ridwan is a male and Barry is a male, then open the class. Then both of them are males. You open the class. If Barry is a female or Ridwan is a male, open the class. Then one of the conditions is true. One of the conditions is true. Ridwan is a male. Then open the class. But if both of them are false, then it defaults to false. So I hope, so that is that about logical operators and logical operation. So one thing I want to point out is we've done sequence, we've done selection, and we've done repetition, right? So the question is it possible for a program to have all these three? Yes. Programs, like in many cases, they are doing all these three together. So every program you see is just a combination of this sequence, a combination of selection and repetition. So if this and that, else if, and while loop, do while loop, like we've seen somewhere here. Where was that? I think we did something. Was it do while loop? Okay, break continue. Yes. No. Look, you can see we use for loop and if here. So sometimes you can have all of them coming together to give you something. So it's just like you are cooking, right? If you are cooking in the kitchen, you'll be following some rules. So do these steps in order. Put water on the fire. If you want to boil rice, put water on the fire. Do this, after this, do this, after this, do this. That is sequence. It is like waterfall. They follow each other. So after this, do the next one. After this, do the next one. Then there is another one, choosing the ingredients. So that is selection, because you are not using all the ingredients at once. You are choosing, okay, what I'm cooking is rice. Then definitely I will need salt, I will need this, I will need that. What I want to cook is eba. Then definitely I don't need salt, I don't need sugar. So why do I want to use sugar? So you are selecting. But even if you want to cook rice or you want to cook eba, they are following a sequence. Put water on fire, pour garri into it, stir it. And while you are stirring your eba, that is repetition, because you continue stirring until a condition is met. And that condition is, maybe it's as sticking, or, oh, I love the texture like this. Then you stop. So everything we do, even in our daily lives, we are using sequence, selection, and repetition. You coming for your exam every Saturday, you are repeating it. And you are selecting, because you selected the courses you registered for. And you're also following a sequence. The sequence is you attend lectures, you do your assignments, you sit for exam, you see your results, you repeat it the next semester. So we do this in our daily lives, and the same thing with programs also. So the recap is for loops. For loops are best for fixed counts. When you already know the counts, you use for loops. When you already know the counts, like I want to repeat something. I'm applying for MIT. I know MIT is what? It's 2 years. I already know. I know the count. It is 2 years. It has 4 semesters. So I'm using for loop. For each of the semesters, I'm attending lectures, doing assignments, doing exams. So I already know the counts. So that is when you use for loop. For each semester, do this. For each semester, perform these operations. Do while loop. So I'm actually recapping now so that we can move to the next one. Do while loop runs at least once. You do something first, then you check for a condition. You taste this food. If it doesn't have salt, then break off. Stop eating it. That is do while loop. Then switch statements. For switch statements, It's just a clean way to, for multiple choices. The question is, can you use another thing instead of switch statement? Yes. In most cases, you'll be using if, else, if, else. If grade over 10, if 90 over 10 equals to, the answer is 9. If the answer is 9, then print this. Else if, check this. Else if the answer is, okay, let's say if the answer here, grade over, let's say grade over, we are picking, let's pick 50. 50 over 10, the answer is 5. If the answer is 5, check, do this. Else if, do this. Else if, do this. Else if, do this. Else if, do this. If no condition is met, else, do this. So we can convert this to an, should we do it now? We can convert this to an if statement. So most times, some people find using if and else if convenient for them to use instead of using switch statements most times. But sometimes some people prefer switch statements. It's just you having many tools that you can use. Then we talked about break and continue. So break is exiting the loop very early, just breaking off or just switching off or switching to another thing. So that is break. Then continue, it continues to the next iteration. So that is continue. It skips to the next iteration. Then we talked about logical operators, where we talked about combining these things, the and, the or, and the not. So all programs boils down to sequence, selection, and repetition. So now we are moving on to the next one, which is methods. So methods. So for methods, I think I have to be faster now because I want us to finish by 7. So for methods are reusable block of codes. Methods are reusable blocks of code that makes programs modular, like in modules, and make programs efficient. So they are reusable. You can reuse them over and over again. So methods are like mini programs inside your program. So they help you to break problems into smaller and reusable parts, right? And the importance of using method is to make your pieces, make them manageable, and also it also improves reusability and maintainability, right? So we are going to be using static methods, right? So another reason why you would want to use method is they reduce repetition. You write them once and you can use them as many times as possible. For example, you have a method called spoon. You can use that spoon as many times as possible. Instead of you building your spoon, after using it, you throw it away, you build another spoon, you throw it away. Why not just have one spoon that you can reuse over and over again? You can use it to open tin, you can use it to eat, you can use it to drink tea, you can use it for anything, right? So another thing with method is they prepare you for larger projects. So methods and classes are modules. Each one of them performs a task, and they are called from the main, either they are called from this main method or from another method. So we are going to see that come into play now. And methods can also have, what's it called? Method declaration. So I'm thinking of an example. Okay, so method is like let's say a blender in your kitchen. So if you put fruits inside, those fruits are parameters, are things you want to use, the information you want to use. You put the fruits inside the blender, you press the button to blend. You pressing the button means you are calling a method, and the method you are calling is blend. That is, you are calling a blend method. And what the blend method is doing is taking the parameters, mixing them up, blending them, and you are getting a value back. You are getting a result. You are getting your juice back. You are getting a return value back. So that is why method, like your blender, you can reuse it over and over again. Use it to blend pepper, use it to blend fruits, use it to blend anything. So you are reusing that method. You are reusing that blender over and over again. So far, you have different parameters put into it, it mixes it up, gives you your results. So you are doing input, operation, output, input, operation, output. So let's talk about, we talked about methods yesterday. We are going to be talking about static and non-static methods. Yeah, static and non-static methods. So static methods, they belong to the class, not to the objects. It's getting confusing. The question is, what is the class? What's an object? So static methods belong to the class, not an object. There is one question that I saw that was talking about this particular thing. Static belongs to the class and not an object. We call static with the class name and the method name. Let me write that out. Okay, static methods. Static and non-static methods. So static method, writing actually makes things slow down. Static belongs to the class, not to an object. So the question is, how do we, if you want to call the class, let's say we have a class named read1, like we have a public, I'm just saying, we have a public class, read1, blah, 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 we have this. If you want to use this anywhere, what you are going to do is you do read1, then you can now do readb equals to new read1, right? And let's say inside read1, what does read1 as is height? Read1 has height. You can now say, so this is a method inside this class. So if you want to use statics, if it is an object, if you want to use this height object, what you are going to do is after instantiating it, you now do read1 readb dot height, right? You call it like this. But if it is static method, instead of doing all these problems, you don't do this. You just call it straight up and it works. You can see the difference. So if it is not non-static, you have to instantiate the object first before calling that method. But if it is static method, you do not need to instantiate the object before. So that means this is an object. This is an object. This is a class. This is non-static method. But if I want to do non-static, I do not need to, I do not need to instantiate an object first. I just need to call the class name and the method. This is a static method. So that is that about that. And the way you call them is, this is the rule. The class name dot the method name. Yeah. So this gives you a static method. This is a static method. So you have to know the difference between the two. And where do we use static methods? We have static method. We've been using them. If we go to, let me check. Should I say this is a static method because we are calling it directly? I'm coming out. I think we've been using them. We have, okay, yes. Scanner is non-static because we have to instantiate it. Input.next, okay, it's part of the I think we use this somewhere, but don't worry, we are going to get to use it now. So non-static belongs, like I explained, non-static belongs to an object, and static belongs to the class. For non-static, Where did I put this thing? Sorry. I was writing. Okay, no, not here. Static. Okay. So for non-static, non-static belongs to an object, like I did here the other time. And so non-static, this is non-static because it belongs to the objects. For a static, static does not belong to an object. And think of it like school rules. The UNILAG group applies to everyone, no matter the course you are studying. Even if you are DLI or you are NIT, they have their rule. It applies to everyone. That is static. But non-static is just like you have to instantiate the object. You have read one. Some things belongs to read one. You have to instantiate read one first. You have to know read one's age from this, because that is read one. Read one is human, and we can have many human, as many as possible. Each human have their own different methods, right? So that is static and non-static. For static, you do not need to instantiate the object. For non-static, you have to instantiate the object. For static, you do not need to instantiate the object. It just goes like this. And let's run an example. I'm just going to, I'm coming so that we won't be having the errors. So let's say we want to, let me give us an example here. So let's say we have a maths test. Yeah. So in here, just going to copy a small code, then I will explain, and you'll see the difference there. So, okay, we have been using it. We'll be using system.out.println. That is static. So why is this rolling? So look at this code. This is a method, maths. You can see it. This is a method. But we are not doing maths equals to maths, new maths. Before we use this, we are not doing this. So we are calling this method, which is square root, directly on maths. And we have another one here, absolute. We are calling this ABS directly on it without instantiating this math. We are calling max from here without instantiating it. So this is pretty straightforward. So we just have to pause. Trust me, I don't know. I'm not 100% sure, but there might be a question on it talking about static and non-static, right? Static method and non-static method. So next, let's talk about declaring methods with multiple parameters. We've been declaring method with just single parameter since, and so do we need it so that we can save time? I think we need it. So how do we declare methods with multiple parameters? So let's use this code, for example. I think I'll be moving faster now, so I'll just be skipping some things that I think might not be necessary. We already have the fundamentals. We just have to reuse them over and over again to see how they come together to give us results, right? So I'm going to be copying and pasting something. So I copy this, then paste it here. So we have this program, and this program, what it does is, it is to find the largest, the maximum of 3 floating points. And the user is going to be entering the 3 floating points, the decimals. And so let me just run this first. Then I'll explain the first floating number input 1 + 1. Then the second one, I input 5.6. then I input 2.3. So it says the maximum of them is 45.60. So that is what this program is doing. So here we have the, let me zoom like we used to do. Here we have the public, this is a method that we've created. We've created multiple methods. And the way they work is that you can see after creating the method, we also have our entry points where we are calling one of the method, which is under method, the main method. So like I said at that time, you must always have your main method, which is the entry points. So we have the public static double max, which is this particular method. And what it's doing is that it's accepting 3 parameters, X, Y, Z, and their data type is double, which is basically decimals. They are expecting decimals. So, and what they are doing is they are returning the maximum value. So what they do here is they assume X, the first input, is going to be the largest. They are now checking against it, just like having a control, then checking against the control. If Y is greater than X, then make maximum value to be Y. If Z is greater than maximum value, which is Y, then make maximum value to be Z. Then at the end of the day, return the maximum value, whatever it is there, return it. So after returning it, we have another method here. So this method is, what it's doing is basically accepting values from the users. So after getting the value from the user, then call this maximum method and pass in all the 3 values you've gotten from the user, then which returns something. And there is one thing I want us to pay attention to. We are using the return statement here, which means you must have the return type, data type here also. If we do void, even the program will be shouting like, guy, you did void. Void means you are not expecting anything in return. You just do Samaritan for someone. You are not expecting any feedback. You just do your own. But here, we are expecting you to give us a value back, and that value must match this data type, which means it must match. If we are expecting integer, this one will be integer. If we are expecting string, this one will be a string. But in this case, we are expecting double. So it must match. And also here, you can see this method. This is not expecting anything, because what this method is doing is asking users to input these 3 numbers. After inputting the 3 numbers, and please pay attention to this. For integer, we are using next int. For double, for floating points, we are using next double. So this must also match what you are expecting from the user. And it must also match the data type that you're expecting. Then we are doing some calculations here. What we are doing here is we have a double, and the variable name is results, and we are calling this method here. Whatever the maximum is out of these 3 values, return it here. So if this is returning something, whatever it returns here, which is the value here, that is what we are going to get inside this, and we are printing this out. And at the end of the day, we are now calling this determine maximum method inside our main method, because that is the entry point. Without this is not going to run. So if I comment this out, you can see it's not showing. And what you have here is the file in the editor is not runnable. But with this, then it is runnable and we can run it. So I do 2.3, 4.5, 1.2, 1.2, and the maximum of them is 4.5. So that is that about that. And then let's move on to method call stack and activation records. We have to be fast. Method call stack. So I'll be skipping some things that I think are not necessary. So what are stacks? Java uses, not just Java, as many programs, many programming languages. Java uses stack, which is last in, first out, to manage methods. And it's something we discussed the last time, that was some months ago. when we did FIFO, first in, first out, LIFO, last in, first out. So last in, first out, the last person to enter, like let's say we have a bucket. Can I say bucket? We have a class, and the class can only accept, two people cannot stay side by side. Only one person can enter. The next person coming is going to stand behind them. The next person coming is going to stand behind them. So that means the last person, if we need to go out, the last person to enter will be the first person to leave. Else, all of us, we are stuck because we only have one door and there is only two people cannot stay side by side. So that is last in. Let me just write that. Stack. So stack is last in, first out, LIFO. So it's used this to manage methods. So when one method calls another, like we've done here, the new one goes on top of the stack. So this method, main method, calls this. Once this is called, this one goes to the top. So we have, let's say we have our entry points is this. We enter here. So basically, this is how to read programming language. Let's say you are managing someone else's code. The first thing is you look for their entry points. You enter through the entry points. What can you see in the entry points? We can see this method. What is happening inside this method? I click on it. It takes me here. So I'm reading this method, blah, 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 blah. I got here. This is also calling another method. What method is it calling? Maximum. So all these methods, it does not matter how I arrange them. I can take this one to be at the top. It doesn't matter. It can be at the top here. It can be the last. I can take this to be the last. It doesn't matter. So far, I'm calling them. So the next one I'm calling will be, it's just like, okay, I enter here. We call determine. I enter determine. Then inside determine, we call another method, which is maximum, right? So it's just like you have plates stacked up. So you put a plate down, you put another plate on top of it, you put another plate on top of it, you put another plate on top of it. If you want to start removing the plates, you have to start to remove them from the top. So that is last, because the one at the top was the last one to come on top. So you will remove the first one at the top, like that, till you reach the last one. So that is last in, first out, and last in, first out. Then argument, promotion, and casting. Then you can also cast variables. Promotion and casting. So you can also cast variables. Casting means you are converting them from one data type to another. You are forcing them. You are like forced conversion. You are, this person is can I use religion? No. So you are forcing, we have int and double, but you want to force both of them to be double. So that is casting. You are forcing them to change from what's it called? From one data type to another data type. And you can only force from what's it called? Is it big? So there are two things. Yeah, let me write them out. There are two things. We have promotion and we have casting. Yeah. So promotion means it's just like you are pouring a small cup of water into a big jug. So you are promoting that water because it moved from a smaller place into a bigger space. So that is promotion. You move from the gates, from gatesman to manager, from your small room downstairs to a bigger office upstairs. That is promotion. Casting is you are forcing you are pouring water from a big jug into a small cup. Definitely some are going to spill away. So that is casting. So you are forcing something bigger into a smaller space. So at the end of the day, some things will just shed off. So that is casting. Then what else can we? So let's talk about scope of variables. So scope of declaration, so that we can end this and we can move on to the next one. So for scope of variables, we have Let me write this out. Scope of variables. So we have local. I miss our last programming class lecturer. Local variables. We have instance, and we have class. So and this is also static. So for this local variable, they exist inside the method that we declare them. For I'll give us an example now. So let's go up. This variable here, double max value x, it is a local variable to this method maximum. Outside this maximum, you cannot have access to this variable anywhere. But this variable can be used anywhere here, like we've been using it. They use max value here, they are using it here, they are using this is local to this. It is local to this. Outside this method, you cannot have access to it again. So that is local variable. Then we have instance. That instance variable belongs to the objects. So I can do, if you do public string name students or student name, public string name student here equals read one. So this is an instance variable because it belongs. So if I instantiate, what can we instantiate? If I instantiate this object, let's say I now do, if I do maximum finder, finder number equals to new maximum finder. So I can have access to, if I do finder, this one not sure. So I can have access to finder dot name students. We've done it yesterday where we have access to. So this is an instance. It's also a variable that it belongs to that object. And we have what's it called? Static also, which is shared across all objects. Right? So the example is that when you write something, you wrote a note on a piece of paper, you know, that is local. It is local to that piece of paper. You can throw it away after use because you don't use it, you don't need it anywhere. But if you write something on your wall, you know, I have my own wall, or let's say wallets. If you put money inside your wallet, I have my own wallet, you have your own wallet. That is an instance because it belongs to you. It belongs to that class. It belongs to that class. It belongs to that object, rather. Then we have static. So static is just like we have public notice board whereby they can post anything and all. Then everyone can see the same thing. Like they can put, okay, you're having your exam at NLT A, NLT B. It is static because everyone have access to it. But for an instance, I have my own wallet. Wallet is what's it called? It's an object. Everybody can have their own object, their own wallet. So I can put money inside my wallet. That money I put inside my wallet belongs to me. That is an instance. Then for local is just like you write something inside a paper, you throw it away. After throwing it away, it becomes useless. But that time that is still on that paper, it is useful on that paper. So that is local. It is local to it. So that is that about that. Then what else can we talk about? Yeah, method overloading. Yeah. So this method overloading is very important. Overloading and overriding. So we get to overriding when we get to, I think, inheritance. And so method overloading. Method overloading means so method overloading, right? So overloading means the same name but different parameters. The same name but different parameters. So you can think of it of like, let's say you have many doors with the same label. On this door, you see enter. this door you see enter, you have many doors, but those doors have different sizes. So you have small doors for kids, you have big door for adults, and you have same purpose door, maybe for difference, anybody can enter, no matter their size. So let's write a program to demonstrate this. We have let's call it overload, because overload test. I think I saw this in one question that the AI generated for me when I was trying to, So let me zoom this out. So let me run this first. Oh, I have an error here. Where's the error? Okay, here. So I run this first. It brought this. So what is happening here? We are overloading a method. The question is, which method are we overloading? As you can see, we have two methods there. And these two methods have the same method name, right? The same method name. So we have public static int square, which is taking a parameter of x. So this method accepts an integer argument of x, and is returning the square of x, which is x raised to power 2, x times x. Then we have another method, public static double square, which is the same name. It has this method name, the same method name. We are overloading it. And here we are now saying, okay, this method is actually accepting a double. You can see this one accepts an integer. This one is accepting a double argument. By double, I mean data type of double. It's accepting an argument, one argument, and we are returning the square of this argument also. Excuse me. Right? And here, we are calling method, the square method. The question will now be, which one of them returns what? Which one of them? So, when the program calls square with an integer 7, this is an integer 7, the compiler automatically chooses the one with int, which is this. It chooses this because this is an integer. So when the program calls the square method, but with a double data type, the compiler automatically chooses this because it sees the data type to be double. So this is called overloading. So the output is what we have here, right? So this is called overloading. And when you are using overloading, what you have to pay attention to is make sure they have distinct parameter lists. Like this one is integer and this one is double. So this is called overloading. Theoretically, I saw it in the book, and when I was reading it, it doesn't make any sense. But practically, we now understand this is what it means. So this is method overloading. So method overloading is when you have the same method having the same name, right? You have two different methods. Let me put it that way. Two different methods, but they share the same name, but they have different parameters. I don't know if that's clear. Two different methods, they have the same name, but different parameters. This is method overloading. So far, we've talked about methods, which they are reusable mini programs. We've talked about static, which is class level, and non-static is object level. We've talked about core stack, which are methods that they are executed like stacking or removing plates on each other. We've talked about type promotion. We've talked about casting. We've talked about scope. And we've talked about overloading, which is same name, but different parameters. So now let's move to array lists.
Hi, Ridwan. Sorry, before you
Yes.
move, I have a question. So
Okay.
when for the for the part where you called out the system.out.printf, right?
Yes.
The second line, right? I see you used a placeholder .2f dot point 2f, right? But for the first one, you used the placeholder D, which is digit, I believe. So
Yeah.
this .2f, what does it mean? Can you just quickly give me a brief
So
explanation?
yesterday we talked about it. We have what's it called? We have percentage S, we have percentage D, and we have
Yeah.
percentage F. And we talked about something. Yes, if we are dealing with, let me do this. Let me do something. So I'm just going to use the 3. We have percentage S here. If I run this code, let me do. We're not calling. Let's not call the method. So if I do 7 here, will it work? Because it's a string. Oh, sorry, format. Let's see. So I talked about, this is 7. I talked about something yesterday. If we are dealing with what's it called? String, use S. If you are dealing with digits. So let me do, I'm just testing something out just to show you. If I do hello, will it work? This is not working. And the reason why it's not working, if I over on this, it says argument type string does not match the type of the format specifier, which is D digits. So this is, if you want to, so this is a placeholder, and we have the 3 types of placeholder. If you are dealing with strings, you use S. If you are dealing with integer or digits, you use D. So S for string, D for digits, F for floating points. So this floating point here is F. So what we are saying here is this is going to output 2 decimal places of whatever thing that is here. If we, let's do 5 and see what's going to come out. And this, let me just comment this out. So if we do 5, you can see our result is 5 decimals. I don't know if that's clear. So if we do just
Yeah,
F,
very clear, very clear.
if we do
Very
just
clear.
F, we just have the floating points, and we are just adding that 5 to control how many points we want. So sometimes if you are dealing with money, you want to have dots 2 decimals. So that is what is happening there. So let's move to arrays and array lists. Arrays and array lists. So I'll be short with this so that we can move to something else. So what we want to do here is we want to learn how to store and manipulate collections of data using arrays. So arrays are fixed size and array lists are dynamic. Don't worry, we are going to get there. So array stores multiple values of the same type. Let's say you want to go to the market. You can have an array of fruits. So everything you want to store there are fruits. Mango, orange, pineapple, banana, and all. Array lists offers flexibility. The question is, at what point or why would you want to use an array? So if you have a fixed data set, let's say you are calculating 10 scores, you can store them in an array because they are fixed, 10. And arrays are also foundation for more complex data structures because you can have different data stuff inside them. So an array is a fixed size and it has it's an indexed collection and it starts at 0. So if you want to count from an array, you count from the index of 0. Then in programming, well, we normally count from even your timing. Midnight is 0, then you have 1, 2, 3, 4, and all. So midnight is you have 23. So instead of it going to 24, it starts from 0 all over again. By the end of the day, if you count everything, they are 24. 0, 1, 0 plus 1 plus the index is 24. The length is 24. So so arrays are just like containers that holds many values of the same type, right? So let me just give us an example of an array. So let's say we have ints, you can see they must have the same type. And the name of the array is going to, I want to call it numbers because I want to store numbers inside it. Then I can say int 5. So they must be the same type. If I do int hello here, then there will be a problem. It's shouting already because this is a string, and I'm saying I'm expecting integer, but I can do string numbers here. Oh, it will not work because this is still integer. So it must be the same type, right? Then let's say I want to have int which is this ages equals to I want to be specific, 21, let's say 25. So this is also an array of ages, and they are all integer, right? This is also an array. So you can access arrays with their index. So the first array here, which is 18, is at index 0. The second one, index 1. The third one is index 2. So what we have here, we have length of 3 items, but their index is 0, 1, 2, right? And you can get the length of an array to know how many items are inside the array using the array name, then dot length. So this returns back the number of items you have inside that array, right? So the question, okay, let me give us an example of array. Let's say you have a crate of egg or a crate of eggs. Each hole inside that crate holds one egg. That one egg is a value inside each of the holes. Each of the slots have to be like almost the same. The holes will be the same size of holes each. And you can access each of the eggs by their position. So the position starts from 0. The position is index. So arrays are 0 based, which means the first element is at index 0. So I'm saying that again. The last length of an array is -1. That sounds crazy. So the first length, the first element inside an array is index 0. The last element, if you want to get the last element inside an array, is index -1. That sounds somehow. So that is, let's do a test for that, and let's see, then we'll move on to the next one. So let's say we have an array test. Time is going already. Array test. And we have our public class and the main method. So what we are trying to do with this program is we are trying to create an array of 10 integers. All right. We are going to initialize the elements with a series of even numbers, and it's going to print the index and the value of each element. So I'm going to run this now, then I'll explain what the code is doing. So let me know if you can see. I can't zoom this out more than this because of what we have here. So the code explanation is that here, this line 3, right? This creates an integer. It creates an integer array named array. It can be named anything, but we are giving it an array. We are giving it array, you know. And we are saying we want to have exact 10 elements inside it. So this is going to be from indices of 0 through 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we are printing out the header for each of the table. You can see it has %s, percentage 8s, maximum of 8 strings. Then we have the header index and that header value. So we are just printing this out. Then we are now using our for loop. So this loops through, it loops through the array 10 times. Like I said the other time, to access the length of an array, you just use dot length. And we've initialized the length of this array to be 10. We are saying this is going to create 10 integers. So the length of that array by default is 10. So this is 10. So it's looping through, what's it called? Through it 10 times, right? And for each one of them, we are saying array counter, this becomes complex. So I said something the other time. What I said was, I'll write plain English now. Let's say we have array. Can I call it array? Let's say we have fruits. Yeah, I'll just call it fruits. So fruits is, we have this, we have, let's say we have mango, we have orange on our list, we have pineapple. Give me names of fruits. Pineapple, we have apple, we have banana. Let me just stop here. We have banana, we have pear, right? We have pear. So if I want to access mango here, what I will do is I will do fruits, which is the name of the array. I will do 0 because it is on index 0. Like I said, we are counting from 0, 1, 2, 3, 4, and pear is at position 5. Their position is, mango is positioned at 0, orange is positioned at 1, banana is positioned at 4, pear is positioned at 5. So if I want to get mango, I'll just do fruits 0, and this is going to give me mango as a result. It's going to return mango for me, right? If I want to access banana, if I do fruits 4, fruit 4 is going to give me banana. So that is how to access what's it called? Access item in an array, banana. So I'm doing this because I want to explain this part. So what this is doing is, we have a here, and we already know our counter now. For loop, the counter starts at 0, then is counter less than 10. This is true because 0 is less than 10. Then it comes here. And what this one is now doing is saying array, you can see these square brackets. That is how to access array counter equals 2 plus 2 times counter. What is happening here? What is happening here is we are saying array, our array, which is the array name. We are saying counter. Presently, our counter is what? 0. Equals to what? That means we are saying any item that is at position 0, for example, let's say our mango, for example. Any item that is in position 0, then must be equals to 2 plus 2 times counter. So like I said yesterday, we must always use parentheses. Else, this might be doing something else. So 2 plus 2 times counter. I believe this to be this, right? So 2 plus 2 times counter. This is saying 2 times counter. What is 2 times counter? Counter is 0. So you're saying 2 times 0, right? 2 times 0 is 0. 0 plus 2 is 2. Then assign 2 to position 0. So let's say we have, I'll call this read1 array, right? So that I can use it for explanation. So I'm going to comment it out because it's not part of our program. So let's say this is read1 array. Should I call it read1? Okay, let me just call it array so that it will be. So let's say this is our array. Our array is going to be length of 10. So presently, our array is what? Our array is empty. So we are now saying push whatever this calculation is to position 0. The position 0 here is what? Is going to be 2. So the next one that we are doing is we go back to our counter. After doing this, we increment our counter. So incrementing our counter, let me return this back to counter so that it makes sense. We increment our counter by 1. So this becomes 1 now. and 1 is less than 10. When this condition is met, go down here, take array and any item in position 1, then do the calculation here. The calculation here is 2 times 1, which is 2. 2 plus 2, 4. This equals to 4. So put 4 at the position of 1 in the array at index 1. Let me use index. Then once you are done, increment counter. Counter becomes 3 now. Counter equals 3. 3 is less than 10, right? Then do this. Counter is 3. So anything at position 3 is going to equals to this calculation. 2 plus 2 times 3. 2 times 3 is 6. 6 plus 2 equals to 8. So put 8 at the next position. 0, 1, 2, 3. So position 3 equals 8. So if I do for, let's do for counter, when counter is 9. So counter is 9 here. Is 9 less than 10? Correct. 9 is less than 10. Then come here, take array of index 9. Then apply the equation here. Counter is 9. 9 times 2 is 18. 18 plus 2 is 20. This becomes 20. Then put it at position 9. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 here, put 20 here. So I deliberately skipped most of these ones because we already know. So I'm just using that to explain. So that is what is happening here, right? So at the end of the day, if increment counter is now 10. So is 10 less than 10, the condition is false. Then this is done for. Then it moves to the next level, which is another counter again. So it does the same thing, and we are adding this to, what's it called? We're adding this to our table. So what we are doing here is pretty the same thing. For counter is 0, do this, and pretty much we are reusing the same thing, the same method all over again. And what we have at the end of the day is this result. So that is how arrays work. Then that is one type of array. Let's do another form of array, because what we did here, we implicitly declare the length. So let's do the one whereby the length is based on the elements. So if I do this now, then I copy this, we are moved on with this. I just want us to understand that because sometimes there are a lot of operations on it, and it's very useful when it comes to programming. So for this sum array, if I run this, let's see what's going to be the output. The output of this is this. Total of array element is 849. So what is happening here is, we initialize the array, we create an integer of array with 10 specific values. You can see it. Then we initialize our total to be 0, and we are doing some operations here. So what we are doing here is basically what we explained. If counter equals to 0, for counter equals to 0, which is the initial value, 0 is less than the length of our array. What is the length of our array? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So sometimes you can be confused. When I was counting, I started from 1. I said 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I said the indexes of an array starts from 0. So they mean different things. Counting is you want to know how many items is inside that array, how many items. Indexing is when you want to know the position of the item. So 87 is at position 0. 91 here is at position 7. Let me see. Is it 7? 4, 5, 6. Yes, that's correct. 7, 8, 9. So these are the indices. So these are the indices. So they are the position. You call them position also, right? So what we are doing here is pretty straightforward. We are saying counter is 0. Is counter less than the length of the array? What is the length of the array? The length of the array is 10 because we have 10 items. So when they ask for the length of something, even if it is a string, they can ask for the length of the string. If the name is read1, what is the length of this name? The length of this name is 1, 2, 3, 4, 5, 6. This is 6. So this is the length of this name, right? So the length is the total item existing in that particular array. So the length here is 10. If counter 0 is less than 10, then perform this. What are we performing here? We are saying total, which is somebody should make this. Total equals to total plus array counter. So what is our counter? So presently counter is 0. We are now saying array counter, which is 0. So please mute. Is 0.
Hassan, Abdullahi. Yeah.
Azan, please mute.
Yeah, I've muted him. So I don't like distractions. I was saying, okay, so we are saying this total is the same thing as total, like this, total plus array counter, because our counter is 0 right now. What is array? What is array counter? What is array 0? Array 0, this 87 is in position 0. So this becomes 87. Then what is our total? Total is 0 presently. Then this becomes 0. So at the end of the day, 87 plus 0 equals 87. What we have right now is 87. Right? Is that so? Yes, that's so. 87. So after this has been done, the operation will be like, oh, I need to increment counter by 1 plus 1. So counter becomes 1. Is 1 less than the length of the array? 1 is less than 10. Then we come back here again, all over again. We do the same thing. So what we are doing again is we are doing total equals to total plus array counter. So presently array is 1 because we've incremented it to be 1. So we have 1 here. So what is array 1? Array, the item in position 1 is 68. So this becomes 68. So 68 plus total, what is total? 87. 87 is, so 68 plus 87 give us our results, and we have the new item here. So you go over and over again till counter becomes 10. When counter becomes 10, 10 is not less than 10. Then this terminates and it prints out the outputs. And at the end of the day, what we have is 87. So that is what is happening here with this array, right? So then what else can we do? So I think that is that about array. Then another thing is, how do we pass array to methods? So we pass array reference, the reference of the array to methods, because because modifications actually affect the original array. So arrays are passed by reference. So changing inside the method, changing the array inside the method changes the original array. So you don't want to mutate the original array. You don't want to change it. You don't want to destroy it. So let's just run something small, then we'll move on to the next one. So we call this array method, let's say test, right? Then I'll just copy and paste this. So I'll explain what is going on. Then let me run this first. So what we have here, so we are talking about mutation, right? We have the original array and we have the modified array. So I just want to show us the reason why we should not, mutate. So we have our public modify array. We have a method called modify array. And what it does, it accepts an array. So in Java, objects like arrays are passed by reference, right? Then the method doubles the value. You can see it here. It doubles the value, and not just the value, it doubles every element inside that value, right? So every element inside this array that it receives, so it doubles it. Then after doubling it, okay. So when modify array is called, this particular method, when it's called, the original array in this main, where is the main? Where have it? Okay, the original array, which is this, in this main method, is permanently changed. So when it is called, so let's talk about the second element. Then we'll come back and explain everything, together. So the second method, we are passing here. We are passing by value. You can see here, the first one we are passing by reference, array 2. The second one we are passing by the value of an array. So what this does is this particular method accepts a primitive integer. It accepts a primitive integer, and always, like I explained yesterday, primitives like integers, like Boolean, like floating points, they are always passed by value. Like value is what you hold, what you have presently, not a reference. They are always passed by value. So this method doubles the value of this variable. And in this particular method, this variable element is local. It's local to this method. It cannot be accessed outside this method. It is local to it. So the result of this is that this is going to change. It's going to change only the local copy of the variable inside this method. It's going to change it. The original variable is not going to be affected, which is inside the array element, right? So let's explain what is happening here. Inside this entry method, the main method, we have an integer. We have an array, which is a list of integers, 1, 2, 3, 4, 5. We are printing this out, original array. So what we are printing out is for every value inside that array, you can see this, for every value inside that array. So we are printing this out. For every value inside the array, we are printing this out, which is, we are printing each of the values out, which is 1, 2, 3, 4, 5. Then we call the modified method. Sorry, excuse me. Sorry, I want to displace sheets. Okay. So for every method, so we are calling this modify array. So what this is doing is we are passing our original array into it. And once we pass the original array into it, it loops, it iterates the whole array, and each element is inside that array. For example, when I is equals to 0, this becomes 0. So what do we have at element 0, index 0, 1? Then this becomes 1. It will now be 1 equals to, the array equals to 1 times 2. Yeah, 1 times 2. Let me say array 2 equals to array 2 elements, which is 1 actually. 1 times 2. So it's actually multiplying, doubling each element in that array. Then at the end of the day, it's returning it, it's actually modifying it. It's modifying that array. So if you want to your array to remain unchanged, what you can do is you can clone the array or copy the array. So how do you clone an array? You can just do int, then you can do copy array equals to your original array dot clone. So you can clone it. So by cloning it, you are working on this only, and this still remains the same. You are not touching this array. You are only working on this. So that is that about array. Then what else can we talk about? So we need to move on. Let's talk about okay, should we? I think we need to move fast. We've talked about array. If you have any question, you can just shoot. So we've talked about array, and I think we should move on to the next topic, which is talking about array. I'm thinking if there is, okay, we didn't talk about the difference between arrays and array lists. I think arrays are fixed size, and array list is dynamic, right? And okay, let's just do an example of array list, so that I think just be like we just brush through it. Someone wants to talk.
Yeah. Good evening, everyone.
Good evening.
Is regarding the one we just finished, where we did the claim.
Okay.
Yeah. So I mean, you said when you use that particular clone, that the original array, which is that array, the one on top, would not be touched.
Yes.
Okay. So I mean, when we scroll down again, we're using that original array inside that modify something.
Yes, because I just show us how to clone. I wasn't using it.
Oh, okay.
So if I want to use it now, I'll just change it here to
Okay.
clone array, and this still remains the same. So what we have inside this clone array is this same thing. So I wasn't using it. I just showed us how to, in case you want to clone, how to clone.
All right.
But at least for the sake of tomorrow, you won't be cloning because we are not writing code. Okay. So this is array list. Yeah. And oh, this will involve a lot of explanation. So I printed something out to my console, display this content, blah blah, contact control, enhance, and all. So we are going to, I'll just brush through it. So what we have here, this particular code, array list tests, it's demonstrating the basic usage of array lists, or to access and to modify a dynamic list of string objects. So here we have this one. This actually creates an array list named items. And this is specifically designed to hold string objects, right? And we have items.add red, items.add blue, items. So this one has 3 elements to the end of the list. Then moving down, we have displaying the list. We have a counter control loop. So this uses the our normal traditional for loop with an index of I, and it's checking for the items, the size of the items, right? So this is going to get the current number of elements inside the item. So items dot get I, this is going to access the element at a specific index. So because I equals 0, this is going to be items.get item gets at 0. So this is going to return the item at specific index. It can be 5, it can be anything, right? Based on the explanation I gave at that time. Then we have our enhanced for loop. So this one, I didn't want to touch it because it's kind of more advanced that than for loop. We call it for each. For each. You can actually Google search to read more about it because it entails a lot of explanation. But the cocoa there is that it's just like giving us a shorthand for our for loop. Instead of doing I equals 0, I less than this, I plus plus, it just do string item of items. So for item in item, should I use in item of? Yeah, for item, one item in items in your array. I don't know. So this iterates over every string element directly inside the array, which is, this is kind of cleaner, you know, but with time, if you want to proceed with Java, you understand it. So this is for each. So this is saying for each item in items. So you can see this as in for each item in items. Is it in or off? I think we use off for objects and in for iterations. So for item in items, perform this. For each one of them, perform this. So then we have this, which is our final display. This one, it adds yellow to the items, to the end of the list. And so this is actually showing that our list, which is our array, which is items, can be dynamic, which means you can add to it. You can, add to a position, get a position, you can add to, you can get the size and all. So this is just like, they call it, I think, so this is an array list. An array list is dynamic. Array is fixed, array list is dynamic. That's just the difference between the two. So I think we can now move to classes and objects. We can move to our object-oriented something. Where is it? Okay, this and this, and we can call it, we can now do, after the thing, we can do the quizzes and questions. So classes and objects. Okay, classes and objects. So here we are going to be talking about, we are going to be talking more about encapsulation, constructors, and composition. We've talked about encapsulation before. We've talked about constructors before yesterday, but today we are going to be adding to it, which is talking about composition. So why do we want to do more of objects? Why do we want to go deeper into objects? We use classes to build robust, reusable code for real-life applications. We already know that classes are blueprints and objects are actual things, right? So let's just go straight into details. Like we have the constructor and there is this thing called this. Then we have static that we are going to talk about more about. We are going to talk about composition and also maybe how Java manages memory, this garbage collection and all. So let's develop a clock or a time class which has hours and minutes and seconds. So we can call it time. I'll call it time test. We'll be doing more than one. So here I'll just copy the code and I'll paste it inside so that we can. I'm coming. Okay. So this particular class, it has a name time1, which is what we have there. It's built to define, to represent the time of the day, storing hours, storing minutes, seconds, and also providing methods to set the time and outputs in both 24-hour and 12-hour, like we've seen here. So let me just, we have to test this. So I'm going to write another time, then I'll explain the two. So let's just do time1 test. So what do we have inside time1 test? So we have to test this. So inside this time one test, we have, let me just run this first, then I'll explain. So what we have here, it prints out the universal time 000, which is 24 hours. Then it prints out the standard time, which is AM or PM. So we have the universal time and we have the what was it called here? The standard time. So what is happening? Let me just go to time one first, then I will explain, then we'll go to the test and explain, and that one should be clear. So here we have a class, time one, and this class is using 3 private integer variables to store the time in 24-hour formats, because this is 0 to 24, 24-hour formats. So then we have the method set time. So this method accepts 3 integer arguments, int, age, hour, minute, and second. And inside there is doing some validations, to ensure that the hour is 0 to 23 and the minutes are 0 to 59. You can see from 0, it must be less than 23, less than 24, which is 23. And here, 0 to less than 60, which is 59. 0 to the second also 0 to 59. So if the input is valid, it sets these primate variables. So if we input age, the value for age, the value for minute, the value for seconds, if they satisfy this condition, then it sets them to the private variables that we have before we set. But if the inputs are not correct, what you are going to get is it's going to throw an error, which is illegal. So right now we are doing error handling. We are using 1 stone to kill 2 birds, or we are using 2 birds to kill 1 stone. So we are doing error handling here. So which is saying illegal arguments, which is this argument, like you've imputed an illegal argument. So that is that. Then next we move to another method, which is to universal string. So what this is doing is it's returning the time. It's returning the time as a string in the 24-hour universal format, which is, you can see, this is 02, which is 2 digits, 2 digits, 2 digits, and we are returning the hour, the minute, and right. Then we have another method, which is to string. So what this does is it's returning a string in the 24-hour universal time. So we are using these formats for it. So it is pretty straightforward. This is the placeholder digits. The second placeholder is holding 2 digits. Third placeholder is holding 2 digits. And we have a string, which is this one, the placeholder, right? So these ones are going to be having the leading zeros, right? Then, so that is that about this. Then if you go to our tests program, the one we are using to test. So inside this program is basically testing the time one program, the time one class. So what we are having here is we create the time objects using this. We initialize it. We create the time object here. Since there is no time explicitly passed to the constructor, the instance variables, which is the hour, the minutes, and all defaults to 0 because they are integer. And by default, if you do not assign a variable to an integer, if you do not assign a value to an integer, it's automatically, this is the same thing as saying 0. This is also the same thing as saying 0, right? So if you do not assign a value to an integer, it automatically defaults to 0. So since we are not passing any constructor, those ones become 0, right? Then we are now doing some printings here. What we are doing here is we are printing, after creating the objects, we are calling the method to universal string. What is to universal string? What is it returning? It's returning this. this format, which is the hour, minute, and second. Then the next one to standard time. What is time dot to string returning? Is returning this format in AM and PM. Then we now set our time here. Time dot set time. What is time dot set time? What is that method? The method is setting 3 parameters. So we pass the argument to it. We are setting time to be 13, 27, and 6. It sets it. Then we now call our to universal string and to string again. Then we print them out and it returns something. So based on this, what we pass to it is 13, 27, 6. It returns 13. Initially, we are getting 0 because we are not passing anything to it. And here we have our default 12, which we've set here. You can see we set 12 here. If the hour is 0 or the hour is equals is the same as 12, then do this, else do this. So then we are now doing another try and catch because we want to undo the error. We are now saying try whatever thing that is said, which is invalid values. So if any of these are invalid, then catch it with this and throw the error out. We are printing the error out in this format, which is, so anytime you are catching something, you are assigning it, let's call this error. Then this one becomes error.getMessage. So we are getting the message of the error, which prints this out. So we are using this to test. So, and that's that about this, basically. So that we won't waste time. Time is fast spent. Move on to encapsulation, because those encapsulation, inheritance, and polymorphism, those 3 are very, very important. So I'm just going to quickly brush through them. So what is encapsulation? Why do we use encapsulation? We use encapsulation to hide data from the public. You can see we did private in second here. This is encapsulation. If I do public string name equals read one, this is not encapsulation because it is public. So if I go to this test now, let's do time. If we do time dots, you can see it brings all the things I can access. I can access set time because it is public. This is set time, it is public. I can access, what else can I access? Name, because name is public. My name here is public. But can I access hour, minutes, and second? No, because they are private, they've been encapsulated. If you check true, you will never see hour, minutes, and second there. But if the moment I change this, let me change this to public. So if I change this to public, then you can now see, you can see it comes first because it is public. So encapsulation is when you put private. It is private to you. You've hidden it. You've hidden the method. It is not public. You cannot access it. So the encapsulation is data hiding. Nobody outside this class can access it. Nobody. So that is encapsulation. So to encapsulate, you always have private fields, and you provide public setters and getters. Like this is public, it's a setter, it's setting time, and this is a getter. We are getting something. This is also a getter. We are getting something. So the difference between setters and getters is, for setters, a setter is not returning anything. We are just setting. Unless you choose to return something like a message like, oh, the time has been set successfully. Yeah. But most times you are just setting things. You're not expecting any feedback. For getters, you are expecting something. So once you have a return, most likely that is a getter. That's a getter method. So that is encapsulation in a nutshell. Then there is something else which is very important. We call it this. I think last time when we are doing this, I explained what this is. This is referring to the current object reference. This. So how can I call it though? So imagine you and your friend, both of you have the same name. We have two read ones in the class. So if I want to refer to myself, I'll say this read one, pointing to myself. So I'm referring to myself. I'm an object. The second read one also is human, is an object. It's a student, an object. Read one, myself, I'm also a student. So if I want to refer to myself, instead of me saying read one, because you are confused, which of the read one? I can say this read one. This is just pretty English. Like in English, you have this, you have that, referring to something else. So this is referring to the current object, because you see this a lot. One example is, let's say we have a class, and inside this class, we have a string. We have a string called color, and we have the constructor, which is accepting color, and we are now saying this dot color, this object, instead of saying car dot color, because we are referring to the same thing. You can see the error is gone. Car dot color equals color. It's still the same thing as saying this dot color equals color. Car dot color equals color. It's the same thing as saying this dot color equals color. So this is referring to the objects, the current objects, right? So, and let's see how that plays out in an example. Let's create another time 2. So we have a lot of more time don't they go. Time 2. So by 8, we are stopping. Anywhere we get to by 8, we are stopping. So time 2. So for this time 2, let's just demonstrate what this is. Then we move on to something else. Then the next thing is we are moving on to, we just brush through inheritance, because that one is also very, very important when it comes to OOP. So you can see what is happening here. Okay, so we have 4 different constructors here. We have the first constructor here. We have another constructor. We have another constructor here. We have another constructor here. So we have 4 different constructors here. So the first constructor has no arguments. It's not accepting anything. And it sets the time to 0, 0. And you can see it invokes time 2 constructor with 3 arguments. This is a complex stuff. Then we have another constructor here. This constructor is accepting just one argument. One parameter, it's setting just one parameter, which is its age, the hour, and it sets all others to 0. Then accepting only age and setting age, changing age. Then we have the third one, which is it has 2 arguments, right? Setting hour and minutes, and then setting the seconds to 0. Then we have this one that is setting all the 3 components, So the constructor use, if you check, they use these 3 constructors, they use this. They use this to invoke the most detailed constructor, which is this. Centralizing along the actual initialization logic. How do I explain this? Okay, don't worry. We'll get there. So then we have another method, which is set time. So we've improved it. This is different from the last one we did. We have this dot hour, this dot minutes, and this dot second. If we check the time 1 that we did, we are doing hour, which is referring to this, minutes referring to this, and second referring to this. But here we are saying this dot hour where is it? This dot r, this dot minutes. I'm coming. This dot r, this dot minute, this dot second. So this constructor is okay. This is a method set time. So it's acting like as a mutator. It's a setter, right? And it handles the validation also, and it handles it differently from the one we did in time one. So it uses a what's it called, a condition. Oh, we missed something at condition. There is ternary condition. This is ternary condition. So this is saying, let me just break it down. So we are using 2 stones to kill 1 bird. So this is the same thing as saying if H, this one, if this condition is true, then you should return H or return whatever it is, return H, else return H equals to 0 or return 0 rather. So what we have here, the short form of it is this. It is clean, it is easier to read actually. You are saying if this, once you see question mark is questioning this. If this and this is true, then do the first one, else this column means else, do the second one. So we are using two birds to kill 1 stone. So we are validating the inputs without throwing any error, because it checks for a condition. If it should do one, else do the second one. If an hour, minute, or second is invalid, out of range, it automatically defaults to what? To 0 instead of crashing the program, right? Then we are now outputting the results. So this to universal string returns the time in 24-hour format, and this returns the time in what's it called, in 12-hour format. Then we can now, let's now test out our what did I do? Okay, let's now write time 2 test. Then we call it what's it called for that one, time 2 test. So inside there, I think after the we should just, or should I brush through our inheritance? Then we just move to something else. Come. So do I still have people here? It's becoming advanced, right? So
yes, my people there.
okay, yeah. What did I press? My console is off. Oh, product. What do I do? My console. Terminal. Yep. Okay. Thank God. So I'm going to run this program now. And what do we have? We have a lot of things out. So what is happening here is that we initialize the first what's it called? The first object here without anything. We're not passing anything to the constructor. The second one, we are passing something to the constructor. The third one, we are passing just to R and second to the constructor. The third one, we are passing the tree, and the first one, we are passing the tree. So, and we have some invalid parameters here. So what is printing out is, this is creating, for time 2, we are creating an object, T1 for this, T2, T3, passing different parameters. So this is the beauty of having a class. So a class with a constructor acts like a blueprint that you can use all over. You can say we use it all over again. We are reusing it for passing different values into it, right? So that is that about encapsulation and constructors. Then we can now move to, we talk about setters and getters. So what else? So let's just move straight to the last one. Should we move straight to the last one? Inheritance. So let's talk about inheritance, then polymorphism, then we call it a class. So inheritance, this is also pretty straightforward. So inheritance, it helps you to reuse and extend code. It creates hierarchies, like, creating a tree. So we have the superclass. Let me use this. We have the superclass and we have the subclass. Okay, we have the superclass, we have the subclass. So the subclass is inheriting some things, inheriting some traits, inheriting some members from the superclass. And yeah, we always have this is a method. You will see it, you've been seeing it. They call it is, sorry, why am I using this? They call it is a, relationship. I call it method. That's a step of time. So what this means is you have car is a vehicle, right? Car is a vehicle. We have Ridwan is a student. So we are going to be seeing is a method. Inheritance promotes code reusability such that you do not have duplicates. You just have the main stuff, then you have people inheriting different parts from it, right? Like we have vehicle. Car is a vehicle, lorry is a vehicle, what other thing? And they can inherit different things. Car has 4 tires, it's a vehicle. A lorry can have 6 or 8 tires. It's also a vehicle. We have trailer, which is also a vehicle. It has 16 tires, 20 tires. So, but they inherit some things. What are the things they inherited? They have engine, they can move, they can carry passengers, they can, they have color, they have this and that. They have some things in common, but then they still have something that distinguishes them from each other. So that is inheritance. So inheritance allows us to create a new class. So that new class is the child. So the child, it allows the child to take on the characteristics of an existing class, which is the parents, while also adding or changing features. Ridwan has a dad. He inherited some things from his dad, maybe the color of his eyes, his skin color, and some other things. But then I still have some things that makes me different from my dad, right? So I inherited some things. I still have the ability to, take on different characteristics, right? Inheritance allows you to avoid rewriting common code. Why do you want to reinvent the wheel when you can just copy some things from it and do it? Why do you have to create another application like Telegram when you can inherit some things, borrow something from Telegram and use it? Why do you have to, create some things when you already have the blueprints? Just copy some things, extend it. Then inheritance models real world inheritance. Like we have animals. Dog extends animal. A dog is an animal because it has 4 legs, it has 2 eyes, but it's different from a lion. Lion is an animal, goat is an animal, but there are some things they have in common that makes them an animal, that makes them animals, but then they still have different characteristics. So that is inheritance. Then talking about different classes, we have superclass, and we have what's it called? We have subclass. So superclasses and subclass have common features, but the subclass derives some things from the superclass and also adds some things to extend the superclass, right? So you can have, like I said, is a relationship. Class B extends class A. Student extends person. A student is a person, but he extends. What makes a student different from a lecturer? right? So in Java, a class can extend another class to reuse its fields and its methods. So an example is this. We can have a class called animal, like I said the other time. So this animal can have a method. Let's call the method, because it's not returning anything. Eat, yeah, animals can eat. So this is going to be printing out, it's going to be doing some stuff like printing out, let me just, I don't want to write it, printing out eating, for example. Then we have another class, which is dog class, dog. Dog extends animal. So this is how to inherit. You write the keyword. So this keyword inherits, extends. You are extending it, you are extending the feature. So this one can have dog and back, and I'll just say backing. I just say backing. I don't want to be writing. Oh, no. I just say backing. So this dog is extending. Meanwhile, we can have another class. You see the, let's call this goats. Goat extends animal also. And we can say void. What does goat does? Is it bleak? Or what do they call it? Bleak. Makes them different. So bleaking. So you can see these can have, both of them have some things in common. They eat. So which means I can do on this particular method now, this eat exists, and this method eat exists also on goats. But then each one of them have their own distinct method. This one is backing, this one is bleaking, right? So dog inherits it from animal. And I think I've said it before. And goat also inherits from animal, right? So the extend keyword, which is this, it is used to create a subclass. The subclass here is this. The superclass here is this, the animal. So one class can only directly extend one parent class. So in Java, in some other because we can have, let's say we have another class called, I think, mammals, because we have some animals that are mammals. So we can call them mammals. So in Java, you cannot extend more than one. Like, you can only extend just one, because we believe like a goat is a mammal because it breastfeeds the baby, and a goat is also an animal. So it has the inheritance from animal and all. But mammals they're also animals. So in Java, you cannot have more than one parent. You cannot, Java does not allow multiple inheritance with classes, right? So it's just like you have one biological father. You cannot have more than one father. But you can still get traits from your grandparents. Your grandfather is not your father. Your father is your father. But you can also inherit some things from your grandparents. So that is called indirect inheritance. So that is the explanation. Then we have method overriding. So method overriding is a subclass can replace a parent method with its own. Like we said the other time, dog barks, all animal eats, but a dog can bark. A dog can also eat. So which means dog can also have like, okay, I don't want to inherit for an animal. Let me just do my own eat, because I eat something different from what other animals eat. So I am here, this dog class is overriding, because this it exists here, it's overriding the parent's method with its own method, right? And if you want to have overriding stuff, you are going to use a keyword which is called override. So this is telling Java like this method is overriding the parent's method. So it's just like your mom cooks rice one way, then you learn from her, but you decide to cook it in a different way. So you are overriding it. I saw Linda, what's it called? Hilda Basi cooking rice in a different way. I said, oh, this makes sense. I can inherit a method. Then I will now override with my own method. Instead of she using salt for her rice, let me just use sugar, you know. So I'm overriding it, right? So that is it. So I've mentioned two things here, which always comes out: overloading and overriding. By now, we should know the difference, right? Overloading is when a method has same name but different parameters in the same class. Overriding is when a child class redefines the parent's method with the same signature. So it's overriding it. Overloading is when you are loading it. You are loading the same name, but you are just loading. Overriding is when you are changing. When you are overriding, you are changing to your own, right? So overloading can be like you have a restaurant menu where rice can be plain rice, it can be fried rice, it can be jollof rice. The same rice, but different ways, different parameters. Plain rice, fried rice, jollof rice. They are rice, but they have different parameters, right? What goes into jollof rice is different from what goes into fried rice. That is overloading, right? Overriding is when you take your mother's rice recipe, but you now cook it in a different way. My mom cooks rice, cooks white rice. We're like, why are you cooking white rice? Why can't we make it? I'm going to copy the way you cook your rice, but I'm going to make it coconut rice. That is overriding. Overloading is the same thing, but in different ways. Jollof rice, fried rice, plain rice. Overriding is my mom cooks something, I'm changing it to my own taste. So overloading can be in the same restaurants. Overriding is, at restaurants A, they are cooking rice this way. Well, I'll borrow their recipe, but I'm cooking it in a different way. But overloading is in our restaurants, we have jollof rice, we have fried rice, we have coconut rice, all the same rice, but different name, different parameters. So I hope that clears it. Then there is another thing, keyword called super. Super. So super, let's say dog extends animal. So in here, let's say, let's have this method called show, and inside there we have super.eat. Hey, what's going on? Super.eat. So what this means is that, let's say you get stuck while you are cooking, then you now call your mom. Your mom is super. You call her, mommy, I've been trying to prepare, but the water is on fire, but I don't know the next thing to do. I know you used to put water on fire. I borrowed that, but I want to now move forward, but I don't know what to do. So this is like you are calling the parent method for help to use our original recipe. That is super. So you are calling the original method to use our recipe. So that is what super is doing, right? Super is just calling this animal version, and is calling the method, which is eat from animal, which we have here. So it is not overriding it, it is calling it to use it, right? Then we've talked about constructors. So when you create...
Hi, everyone. Please, just a question.
Yeah.
So this, just to be clear, so are you saying anytime we extend and we call the super class, if we're not going to override, we should always use the super to call the method?
Yes.
Okay,
Always.
so we can't just use extend and we just move on with our life and it knows it needs to call the method.
Well, no. Don't get me wrong. If you use extend, every method that's what's it called, that exists on the parent class, you've inherited it already. Every method. There are some ways whereby you call the super to now say, okay, this is what you want to use. I think the best thing we can do is, because even me, sometimes I get very, very confused, we can do more research on it. Actually, let me just put it that way, so that I don't keep beating about around the bush for it. Sorry for that. But we can actually Google search now, like, right? Should we use when to use super? Yeah, when to use super in Java. I don't want to do this, but we are doing this. You can see. So it's okay. It's making sense now. They said to invoke the superclass constructor, because when you are inheriting, you are not inheriting the constructor. But if you want to invoke the superclass constructor, you use super, right? So when super is kiniko, we can read more about it. Basically, this is just for it, Sha. So it's just like you want to inherit. So we have an example here talking about animal, and you want to, this super now calls the animal constructor, because when you inherit, you are not inheriting the constructor. But once you call the super now, you are calling the constructor. You are now inheriting the constructor, calling it with it, and getting your result back. So I think that clarifies that, Sha. Yeah. So shall we proceed? We can read more about it, because most times it can be confusing. And one of the things I was grateful for was when React.js stopped using super. So
please, I'm so sorry. Can you iterate a bit about overloading?
Okay, overloading. Where did I use overloading somewhere where I was calling the same method? I would love to. So I'll just explain, Sha. Overloading is when your own done too much. You cook jollof rice, you cook fried rice, you cook coconut rice, you cook French rice, you cook Chinese rice, you cook, like your own is just too much. That time when people were using Buchi mix to do a lot of things, they were using Buchi mix for different things. The same Buchi mix, the same method name, but different parameters were going in. You are overloading it. That is overloading. Like, I really wish I use this somewhere, but theoretically, that's what it means. So it means like
you overload test. Sorry,
what
you overload test class at the top. There's a overload test class at the top there.
Oh yeah. Thank you for that. So look at this. We have a method there. This is square method. We load it with, it's expecting int of x, integer of x. We now load it again. Instead of expecting integer of x, the same thing, we are recreating the same thing. Instead of expecting integer of x, now we are expecting double y. We are overloading it. You can now reload it again and do something else. So let's say static double, instead of double, can I call it, I'm just testing this out, I don't know if it's work, string, then this is string, and this is z. And we are now saying return z. So this is overloading. I've overloaded the method, which is square method, with different parameters. So this one is preparing jollof rice. This one is preparing white rice. This one is preparing Chinese rice. But the same name and different method, different parameters. That is overloading. It is still inside the class, inside a single class, inside a restaurant. We have, inside this restaurant, we have rice. So the only thing we have, the name of our restaurant is Ridwan Rice. That's the name of our restaurant. But inside this Ridwan Rice restaurant, the only thing you can get here, I'm just saying, for example, the only thing you can get here is rice. We have Chinese rice, we have coconut rice, we have jollof rice, we have white rice, right? What goes into them, into your plates, even if I served 3 recipes, what goes into them is different. That is overloading. Like overloading, you are loading it too much, your own done too much. That's just the analogy. That is overloading. Then overriding. Where was I? Where was I? So sorry, I was there. Okay. So overriding is Where is it? I think I wrote it somewhere. Okay, yeah. So overriding is, we have Barry restaurants, we have Ridwan's restaurants, right? Ridwan copied some things from Barry. Ridwan is now changing it to his own taste. That is overriding. You use this override. Like we have here, we have animal. Dog is inheriting from animal. Dog is now saying, you know what? Whatever thing you have inside your animal, which is this eat method, I want to redefine it to my own taste. If this one is printing out eating, this one should now print out I am not eating. For example, I am not eating. I'm just saying. So overriding is, you are copying something from someone, you are not changing it to your own taste. You copied my assignments. Instead of you now putting my name on your assignment that you've copied, my matric number, you now delete, like you change it to your own taste. That is overriding. I don't know if that makes sense. So for overriding, I'm getting my assignment from somewhere else, from another object. So you are copying from another place to your own place and inheriting from somewhere else to yourself, but now changing it to your own taste. That is overriding. Overloading is, within this house, we are eating rice, but we have different types of rice within the same house. Overriding is, in another house, in another object, I'm copying from house A, but I'm changing it to my own taste. I don't know if that makes sense. Does it make sense?
Yes, thank you, Ridwan.
You're welcome. So now we are moving on to polymorphism. So did you do any? We didn't do any example yet. Okay. So polymorphism, a parent's reference can hold a child object. So let's say we have our animal class, and we are now instantiating an animal equals to new animal, for example. Or let's say new dog. Yeah. Yes, new dog. That is it. So you can see on a normal day, what we would have done is animal A equals to new animal. Equals to new animal. This is what we've always been doing. But now we are doing something different. We are saying animal A equals to new dog. It's getting more compound. So the parent reference can hold a child object. This is the parent animal. This is the child dog. The parent reference holding a child object. And if you want to call this now, instead of, if you call a.eat, this is going to be calling the eat version that exists, called dog's version. You know, in animal, we have eat. Let me just copy this and paste it side by side so that it makes sense. In animal, we have eat. Then we have our dog class, which extends animal, and it also has its own eat. So if you are doing polymorphism, that is going to, you know, if you do it this way, instead of, if you do initially, if we do this is going to call the dog's version of it. Let's do it here. Void. Okay, let's say we've override it. Yeah. So if we do this a.it, this one will now be calling the dog's version, not the animal's version of it. That is poly. So polymorphism means you know, something that you can use in different places. It takes different forms, many forms, poly, and it morphs into many different forms. So that is it. And you can think of it like a remote control. So the remote is labeled TV remote, which is the parent type, but it actually controls a smart TV, which is a child object. So you can get extra features. So we have a remote, which is just a normal remote, but it controls a smart TV. I'm thinking, can I get any other analogy? So that is polymorphism. Then we have we have another thing called abstract class, which we've done the other time, but I just want to abstract class. So abstract class cannot be instantiated. For example, this is not an abstract, this is non-abstract class. So if I want to do abstract class, or normally if I want to do a normal class, I'll just do animal A equals new animal. Then I can now do A dot it, right? This is non what's it called? Non-abstract. But for an abstract class, I'll just do A dot E directly without instantiating the objects, the class. So, and they can write abstract classes like with the keyword abstracts, like abstract class, let's call this shape, class shape. So it can have abstract method also, void, it can have draw, right? So abstracts are like architectural plan, right? And you cannot live in it. You have the plan on a paper, you cannot live inside it, but you can build real houses from it. So which is this subclasses from it. So those are abstract. So if I have this abstract class, I cannot use it for anything, but I can build subclasses from it, right? Then we have, so we are going to, I will use a code to explain. Then we have protected members. So protected members is something we've done before, which is, talking about encapsulation. So let me just, let's do this last example to explain everything. So I'll just copy this out. 802 already, wow. So after this, we'll just go straight to the exercises, and I might take like 10 minutes break because my throat is dried already. So I'm going to write a code, then I will explain it, and we can just call it a time. So let me just call this permission. Yeah, you can talk. I can check the class window. Yeah, so I have this commission, then we can build a test for it. So I will explain what it's do, what they are doing. Commission, employee tests. Yep. So in here we have some things. We've covered the whole book in 2 nights, actually. So let me explain from the first one, which is this. So we have this class, commission employee, and what it's doing is we have some variables, private variables here, holding data. So the first one, and there is something here which I just introduced. You can see it. We are seeing this for the first time. It is called final. So what does final means? Final means it can only be set in the constructor. Final. Don't worry, you get it. So we have first name, we have last name, we have social security number, SSN, we have the gross sale, which is the weekly sales, and we have the commission rates, which is going to be percentage of sales end. So here we are going to be using 0.1 for 10%, 0.2 for 20% and all. Then inside this constructor, You can see it. It has the same name as the class name. Is a constructor. Inside this constructor is taking 5 arguments: 1, last name, 2, 3, 4, 5, right? Then after taking the 5 arguments, it's checking if the gross sale is less than 0. If it's less than 0, it's throwing an error. Then checking again if the commission rates, so which means this commission rate must be a percentage greater than 0.00. What's it called? Checking if the commission rate is less or equals to 0.00 or greater than or equals to 1.0. And if the validation fails for either rates or the sales, it's going to throw an illegal argument exception error. Then moving down, if there is no error, it's going to set, if there's no error, all these arguments is going to pass them into the variables we've set before. Then moving down, we have the getter. This gets the first name and return it. And we also have the another getter getting the first name. So we have getters. This is getting the social security number. And we have a setter. And what this setter is doing is it allows we have 2 setters actually. Is it 2? Okay, the commission rate and also the gross rates. So these 2 setters, they allow the the gross sale and the commission rates to be modified after the object is created. So both setters include the same validation logic. So this is checking if the gross rate is less than 0.0. This is also checking, it also has some validation logic here and is throwing some exception, right? And you use this so that there will be data integrity, so that someone else will not do what is not. So then moving down, we have another method here called earnings. So what earnings is doing is calculating the employee's pay using this formula. This gets commission and gross sales. So this is saying is going to return something like earnings equals to commission rate times commission rate multiplied by gross sales, something like this, right? So it's going to return that. Then we have something else that outputs something to the console for us. So, and this output, it has this override. So this override, it overrides the base method to provide a detailed formatted string, what's the English? Representation of the employee's data, which includes their full name, their social security number, their gross sales, and the commission rates, right? And we have the formatting here. We have SSSSSS, and here this is formatting these two to 2 decimal places, .2f. So you have to pay attention to that, right? Then moving on to our commission employee, we have some. After this, we'll just move straight because we are done with what's it called? The whole class. So what this is doing is we have the commission. We are what's it called? We are instantiating the commission employee objects. We can see it's commission employee. We give it a variable name. We have this object set to it first. Then after that, we are now printing some things to the console. Then we are now using the getter to get the first name, getter to get the last name and everything. We are doing all this here. Then after this, we are setting the gross sales to be 5,000. We are setting the commission rate to be +1. And this set it to 10%. And at the end of the day, we are printing something to the console. So if I run this now, let's see what we have on the console. So I run this, we have this. Oops. This is, oh no. So this is what we have. So the first name is what we instantiate it to be, Sue. We have Jones. We have the security number. we have the gross sales. This is what we instantiate it to be. Then down, we are now updating the record, right? So updating the record, the first thing we use some getters to get all these things. Then we now update the record with employee, set gross sales, and all. So this returns the first thing, and when we updated the record, it returns the second stuff because we called it. So I don't know if this makes sense. So basically, that's just Tisha. I'm already having a headache. So moving on, we've talked about inheritance, and we said inheritance allows you to reuse code. A child inherits from parents. A child extends parents. Then we talked about overriding. So overriding is when a child replaces his parents' method. That is overriding. Overloading is when the same method with the same name, when we have the same method with the same name but different parameters. That is overloading. We talked about super. Super is used to call the parents' methods constructor. We talked about the parent, what's it called? Polymorphism, which is a parent reference, but it's having a child behavior. Then we talked about abstract classes, which is a blueprint for super subclasses. Sorry. Abstract classes are blueprints for subclasses. Then we talked about all classes inherit from objects. So that is that about polymorphism and but let's take an example of polymorphism so that we can see how that plays out. So let's say we have a shape. So inside this shape, so after this we are done actually, because even myself I'm tired. So inside this shape, so you can see this is like we said the other time. It's just polymorphism is just like what is it called? Like a blueprint also. Then let's create another shape. Then I will explain what these two means. So we have a shape. Then let's create circle. So inside this cycle, we can now test out what's. So you can see. So we have a shape, which is this, and we have this. So what is happening here? Inside this shape, we have public abstract class. So which means this class cannot be directly instantiated. It means you cannot come here and say shape, new shape, let me call it this way, new shape equals to new shape. You cannot do it this way. Oops. All right. Equals to new shape. So you cannot do it this way. It's actually, you can see it's shouting already like shape is an abstract, cannot be instantiated. So you cannot instantiate an abstract class. You cannot instantiate an abstract class. So going back to the shape, then we have public abstract void draw. This is an abstract method. And if you check this code, okay, we didn't use it here. So this is an abstract method, this draw. It has no body, like this, unlike our normal method, whereby it will have this body of code. It doesn't have body. Number one, any concrete subclass that extends shape must provide its own implementation for draw. Like this method now. Any concrete class. So this is an abstract class. For an abstract class, they will implicitly, is it implicit or explicitly? They will write abstract in front of it. But any class that doesn't have abstract class, it is a concrete class. So a concrete class like this, if you want to extend shape, you must you must implement your own method. So if you have many methods here, public, abstract, void, kinikon, draw, I can do, what can we do? Distort, let's say distort. So if I do this, definitely this cycle must also, you can see it's already shouting, it must also implement its own, what's it called? Its own, is it distort? Its own distort. If not, it won't work. So this enforces common functionality across all shapes. So if I have circle here, if I have another, what's it called, another class, call it square, and I say this square extends, is going to inherit shape. Yeah. So you can see it's already shouting because I'm not, you can see class square must either be declared abstract or implement abstract method draw in shape. So I have to implement whatever thing. So it is good because it enforces common functionality across all the can I say the children. Let me put it that way. So then here for circle we have this is extending shape, right? This class is a concrete class. It's a subclass of shape, right? And we have this override public void draw. This provides the required information for the abstract draw. The abstract draw method defined in the shape abstract class, right? So the functionality is that when draw method is called on circle objects, it simply prints the message, draw a circle. This fulfills the contracts set by abstract. So abstract class sets a contract for the children. I don't know how to explain. So you can have as many children classes, but they have to follow that blueprint. So I think that is that, about that. Yep. So that is that about that. Do we have any question? But make sure it's a question I can answer, I beg. I'm also learning, I'm also a student. So that is that about that. And I think we are done. What we haven't touched, but I think it's something we can learn about, is interface. But then time is gone. We are done. So do we have any question? In the absence of no question, I will just move on to our what's it called? Okay, let me present this. I'm coming. If anybody has any question, we can talk. But then we have to be fast because my